and a very warm welcome to our course on Hadoop Administration. I can see a few people joined in, so I think we should give another minute for the others to join in. So in the meanwhile, I will give a brief introduction about myself, and before that, can somebody confirm me that am I audible and clear? Like the voice quality is fine, you guys can hear me properly. Oh, great. Thanks for confirming. Haha. Naveen is saying crystal clear. Thanks, Naveen. Janardhan is asking, do we have class today? Yes, Janardhan, we have started with the class. So the class timings are from 8 a.m. Okay, so in the meanwhile, others join in. So why not quickly start with a quick introduction? So let me give a brief introduction about myself. My name is Aman and I will be your instructor throughout your course. And I have around 10 years of experience mainly into the Linux performance tuning and Hadoop administration. So I've been working corely on Hadoop for the last 4.5 years. And I work with a very large MNC which has a very large cluster setup for Hadoop. So that's all from my side, and you guys in the audience can quickly introduce themselves with a quick liner, let's say saying whether they have any prior exposure to Hadoop or not, and what are their core areas. So I think we can start alphabetically, or maybe, okay, let me just see all okay, let's start with Ajita. And then because you all guys will be on mute, you cannot speak, so you can only type in. So please can everybody leave a short description about themselves in the question answer sections. Okay. So Naveen is saying that he is working on MS SQL. Okay, he's a DBA with 6 years of experience. Okay, so you are from Microsoft Technologies. Okay, great. So Naveen, do you have any exposure to Linux? Okay, this is not a requirement for course, but just I'm asking because things will be easier if you're comfortable at least with the Linux shell. But we have, as we go along the course, I will show you if somebody who is not from let's say a Linux background, how he can come to pace with the very basic stuff of Linux. Naresh is saying that he's working as a system administrator. Okay, great, Naresh. Jonathan is saying that he's a senior Oracle DBA with 10 plus years of experience. Oh, great. Welcome to the class, Jonathan. Badri is saying he is having 9 years of experience. Okay, which domain, Badri? Okay, working in Hadoop for last 1 year. Okay, great. Okay, we have Will. Am I saying your name correctly? Can I call you Will or Will? How you pronounce that? W-A-E-L? Well is fine, right? Okay. So he's saying that he's into data warehousing, and he's an architect with 16 years of experience. Oh, that's great. Really good to have you on course. Ajitab is saying that he is working into MSBI. He's working on MSBI, and he has around 6 years of experience. Okay, good. Muthu Lakshmi is saying that he is an admin on Informatica. Okay, great. So you use all the ETL extraction tools and all. Great. Okay, Naresh is saying that he does not have any exposure on Java. So that's fine, because see, if you go for a core Hadoop developer's track, right, then the requirement for that is having a base or solid foundation in Java. But for Hadoop administration, you do not need to know Java, right? It's entirely different from that. So we'll see what bare minimum you should know about Java. Okay, Janardhan is saying that he has 3 years of experience on SQL Server, 2005 and 2008. Okay, great. Oh, Badri is a pig and a hive developer. Oh, great to have Badri in the class. So I think you will find a lot of things at ease when we go along the course. Madhu is saying that he is a SQL DBA with 7 years of experience, and he's totally new to Hadoop. Fine. Okay, great guys. Okay, Shamik is saying that his core area is Unix. Okay, great. Okay, welcome once again to everyone to the course on Hadoop administration, and I think we should get started, and as along people join in, so we will introduce them. Okay, so let's see how the course flow is and how things work. Yeah, right. So I think few of you might have already attended some course from Edureka, so they might be familiar with the flow of the classes and what things or what tools they have at their hands. But let me give you a quick kind of a walkthrough that what goes on when we go along the course. So one will be the most important part will be a live classes. So this is a live class, so where you will be interacting directly with your instructor. So it will not be like a recorded session or anything. So you will be directly interacting with your instructor. You can put in questions and all that. And I like a very interactive session, right? So instead of me always talking, right? So it's always better that people come in with questions. They can post in questions, right? And because no one else can see what the participants are typing, so I will kind of broadcast the question what particular participant asks, so that everybody in the audience is aware that what I'm referring to or answering to. So the most important part is live classes. So all the classes which we do, right, they will be recorded, right, side by simultaneously, and they will be uploaded into an LMS, right, so which every participant will have access to, so that they can go and refer back to the recording at their convenience. So this is also a very important part, right, because sometimes what happens, you might not be able to attend a class, or let's say you want to go back and look at some concept covered in the class, so you can play the recording. You can download the recording if you want, or you can play it on the LMS site itself. Then we will have module-wise quizzes and assignments. So after every lecture, there will be an assignment which will cover the module which we have talked till, and also some sections from your previous classes, right? It will be kind of a build-up from your previous week's classes. So it's very important that you do all your practical assignments after the class, right? Because you will have good enough of time on your hand to practice them. Because in Hadoop administration, we will be doing lot of hands-on, right? Okay, theory is there. Theory is important to understand the concepts, but the most important thing is the hands-on. So it is very important that you flow with the class, set up bare minimal at least one machine, right? So we will talk about all that. Then the another great thing about the course is you will have a 24/7 on-demand technical support. Right, so let's say you are facing any problem setting up your cluster, or you have any question, so you can drop an email to Hadoop admin at edureka.in. So there will always be somebody sitting there and watching that email distribution list, and you will get the prompt reply. Right, because what will happen is, let's say you want to reach to me directly, right? I'm your instructor Aman. So it might not be always possible for me to be available or checking my email. So the reply might take some time. So the best way to reach out is to reach Hadoop admin at edureka.in. So everything is given in LMS, so you don't need to remember or anything. So that way you will get a very prompt reply. We will be looking at different cluster modes, right? So what is the scale in, let's say we might run only one single node in a test environment, where let's say a typical dev is testing his code. Another environment could be a medium-sized cluster, a small organization, let's say having around 10 to 12 data node, right? Simple 10 to 12 nodes, or a very large deployment. And also we will be looking at different versions, like how different flavors of Hadoop fit in. And there will be also an certification exam at the end of your course. So this is little bit different from the way how Cloudera does it. The Cloudera's exams are mostly objective type, right? So you will have, let's say, 4 choices and you have to select one which is the right one. But in the case of Edureka, you will have a kind of a hands-on lab. So question might be, okay, set up a Hadoop cluster, 2-node cluster, or set particular parameter, right? So it behaves in this particular way, or let's say set up a block size, right? So it will be much more hands-on kind of a thing. And you will have a lifetime access to the LMS. So let me show you what LMS is. So this is called LMS. So when you log in, so you will see a page which is Learning Management System. LMS stands for that. There will be discussion forum as well. So if, let's say, all the participants of a batch want to start some discussion, they can do here. This is the email I was talking about. So if you have any queries, you can quickly drop an email to Hadoop admin at edureka. So what's basically the flow is? Let's say in a Hadoop administration class, somebody doesn't know Java, or there's no such requirement of participants to know about Java, but you need some little bit essentials. Let's say what is Java C, what is Java, how to set up a path. So there will be some essential docs in the LMS which will be talking about, let's say, Java installation guide, right? Then if somebody wants to do a deep dive, right, so they can refer to, let's say, a Java class 1 PPT, or an assignment which is very specific to Java, and there will be very detailed docs available for Java also, right? But for an admin course, you do not need. It depends upon you how deep you want to go for Java. But the basic what you need is the Java installation guide, right? How to install Java on a Linux or Windows, whatever platform you are using. So another thing will be section like Hadoop installation, right? So we will cover everything, but I'm just showing you how the LMS look. So there you will have how to set up, let's say, a single node, multi-node Hadoop cluster, right? How you install Hadoop on, let's say, a CentOS, right? So those kind of setups will be there, so which will give you kind of an idea how you can go with it, right? How you can do the installation. So all these things we will look in detail. So I'm just giving you kind of a heads up to see, go and familiarize yourself with LMS, what things are available. And after every class, let's say your entire course is divided into 6 modules. After every class, you will see a class recording being uploaded in this class recording section, and you will find the slides which were used in class, right? And you will also find some basic Linux command, right? So let's say in the audience, as some people were saying, they are not from a Linux background. So this will tell you the bare minimum Linux commands which you need to know to set up Hadoop. Right? They will be very simple. Let's say an ls command, a set path command, right? Or a change directory command, right? Or how to change the permission of a directory. So very basic commands will be there. Then there will be kind of a PPT which will talk about, let's say, Hadoop hands-on, right? And there will be a assignment and a quiz section for each module, right? There will be assignment and a quiz section for each module. And what another important thing you will see is there's another section which says Hadoop installation using CentOS. So what many of the participants prefer is they prefer setting a similar environment which their instructor is having itself, right? You can do whatever way you want, but if you want to, let's say, want to set exactly the same setup which I am using in my lab, or right, so you can refer to this document. So this document talks about how I have done my own setup in a virtual machine. So you can refer that. So this just is kind of an overview. So currently you guys don't need to worry because we'll be going in detail for each and everything, right? So our entire course is divided into 6 modules. Okay, sure, Shamik. Shamik has a question here. So he's saying, how is this training aligned with real life scenarios? Okay, so I will come to that. So how this course flows. So as I was telling, this course is divided into 6 weeks. So every week, right? Let's say if we are in week 2, it will be kind of a build up for week 1, right? Week 3 will be build up for week 2. So it's very important to be in touch with what you have covered, right? Go home, at least set the bare minimal cluster, what we will cover in the class, because next all steps, let's say commands, backup, recovery of a Hadoop cluster and all that will be dependent on whether your previous particular lab was working or not, right? So you have to be with that. So we will see all that. So in week 1, which is today, we will be understanding what big data is, right? And we will be looking at Hadoop components. What are the very important components of Hadoop, right? And we'll be looking into introduction of Hadoop 2.0. It's a new framework which has come into picture, which we called it as MapReduce Framework 2, or some people called it as YARN as well. So YARN is yet another resource negotiator. So for the time being, you can forget about all the buzzwords which we are talking. We will look at everything into detail. So okay, I have another question here from Will. Will is saying, I'm taking big data with Hadoop. I had installed CDS3. Any impact if I install CentOS? Okay. So what Will is talking about? Okay, we'll come to that, right? I will show you my setup, then it will be very clear. Okay, so what will be the topics for today? We will look at what is big data, right? Because nowadays everywhere you hear the buzzword big data. Everybody is talking about big data, right? Every company is trying to jump onto the bandwagon for Hadoop, right? So it's very important to understand whether you need Hadoop or not, right? For your organization or for your business or not, and how all of a sudden so much of data has come into place, right? So we'll look at what is big data. what are the limitations of the existing solutions, right? Why we need a distributed framework like Hadoop? We have something like in another distributed computing frameworks, let's say for example a parallel computing framework which is MPI, right? So how it doesn't scale to what we need. Then we look at what problems Hadoop solves, right? How it addresses the problem. Then we will talk about the Hadoop ecosystem. What are the core components which make up a Hadoop? We will talk about the MapReduce software framework, and we will also talk about Hadoop cluster administration roles and responsibilities. So this is in line with the question which Shamek asked, that how the course is related to the practical scenario. So here we will cover about, I will give you a brief discussion like what is the job market for Hadoop administration courses, right? Or what are the roles which a typical Hadoop administrator plays in an organization, right? And then we will end this week's class with a little bit of introduction to Hadoop 2.0, because after that we will be looking into all the details of Hadoop 2.0, but I will end the class with a brief introduction to Hadoop 2.0. Okay guys, so let's get started. So the very first thing is, what is big data, right? How all of a sudden so much data is coming into picture, right? It's not that data was not there, but we were not kind of capturing that data initially, and we were not concerned about making sense out of that data, right? So let's look at this. So the very first thing which big data talks about is lots of data, like terabytes or petabytes. So when you ask somebody, let's say, what is big data, the very first thing he will say is enormous amount of data or large amount of data. But we will look at, it's not only about the size of data, but there are other factors also important when we talk about big data, because that's why Hadoop framework has come into picture. So it will be better for us to understand why we need Hadoop, right? Why the traditional systems will not scale up. So why we are getting so much of data? One important reason is there is lot of automation in place, right? Now you don't have to sit in front of a system or do some commands and generate logs and all that, right? So you have automated systems in place which will keep on working without the human intervention, right? Automation might be in anything. It might be a simple home automation, right? Automation of your home appliances. It might be an automation in your, let's say, a data center, right? So it's generating more and more logs day by day. So the size of logs being generated is very, very large. So you need some platform or a framework which can handle that. So let's say a typical example. So what do you think, what could be the data in, let's say in the picture which is talking about, showing a airliner, right? It shows an airline jet, collects lot of data. So what could be the data, let's say in the case of an airlines, which we need to bother about? Can somebody quickly tell me like what kind of data an airline might generate which we need to bother about? Okay, so Miftah, hopefully I'm saying your name correctly, Miftah, right? So he's saying weather data. Badri is saying cockpit data. Will is saying flight info. Muthulakshmi is saying black box, right? And Ajitab is saying cockpit voice, black box recording by Naveen. Yeah, absolutely correct. So just imagine in a simple airline, there will be a lot of sensors. There will be sensors for air pressure. There will be sensors for, let's say, a wind velocity. there will be sensors for the cargo load. And as many people said, there will be a lot of data being generated, let's say a cockpit, which we call it as a black box, right? All this data needs to be collected and make sense of, right? During a single flight. So best example is British Airways. So British Airways is currently using Hadoop on their for analyzing their flight patterns and the customer behavior, right? So how you will allot seats to the customers, because they have a, let's say, a loyalty plan. There's a customer who flies frequently, for example, with, let's say, a particular airline, and he prefers, let's say, a window seat, or let's say a particular seat in the plane. So when he books in the very next time, he doesn't have to bother about, let's say, selecting the seat and all that. So the decision is automatically made by analyzing his past trends, right? So it helps in a lot of fine-tuning and having a better understanding of your customer, which is very good for the business. So the data which we talk about, data is not just about from, let's say, only from an engineering perspective, right? It's not just about, let's say, the technicalities of an airplane. It could be about the passengers as well, right? What is their trend, how frequently you need to have a round trip time, or how frequently you need to have a flight on a particular route. All these decisions can be made only if you have data with you, right? So one is having data, and then kind of processing that data is also very important, right? So this is what an example is. Let's say there will be so many examples. Another very good example is SETI, right? The program SETI, which is Search for Extraterritorial Intelligence, right? It generates so much of data in one particular day. So you need a system which could process such a large amount of data. Another very good example is stock exchange. So let's say I'm interested to buy a stock. Let's say any particular stock from, right, which is listed on, which is into the public listing. So before buying that stock, obviously I will study some history, how the trending of that particular stock has been, right? How it has behaved in the last certain period of time, right? To give you that kind of prediction or that kind of a graph, you need to have historical data. You need to have data for, let's say, a minimum span of time, let's say 6 months, which will be able to help you to make a decision which is the right stock, right? And also the very important thing in the case of a stock exchange is the criticality is money here, and how quickly you can compute that data. So it should not be that, okay, I have 6 months of data with me, I run some processing on that data, but it gives me answer after 1 week. Your process runs takes so much time to finish that it gives you an answer after 1 week. So then it doesn't make a sense, right, for a stock market, right? A guy who is interested to buy a share, he is looking for quick quotes. So we need a platform to address two things. One, the size of data, and how quickly you can make sense of that data. So very important thing. There's a very interesting definition by IBM. What IBM says and what their observation is, what are the characteristics of big data? So as I was saying, the very first thing which comes to our mind is the size of data. But it's not the size of data, right? It's just not the volume, but it is also the frequency of data. How quickly you are generating that data, right? So this is known as frequency or velocity of data. So we call 3 V's: volume, velocity, and variety of data. Data might be a simple text, it might be server logs, it might be a sensor data, it might be audio video files, it might be anything, right? So typical case could be, let's say you generate 1 terabyte of data at the end of day. Let's say there's some process in your data center, or let's say in your server farm, which kind of, let's say at 6 p.m. in the evening, collects everything and writes a log or a data of 10 terabytes or 12 terabytes. And another case could be within an org, you might be having a use case where instead of writing 10 or 12 terabytes in one go, you might be writing, let's say, 1 terabyte of data every hour. So after 10 hours, you have 10 terabyte of data, but within a time frame of 1 hour each. Right? So there might be different use cases within an organization. Right? So this is very important to understand. So frequency is very important, how quickly you generate data, because your use case will be entirely different if you are processing all 12 terabytes of data in one go and processing a data which is coming, let's say, in increments of 1 terabyte per hour. So another thing is our data is growing exponentially. So there's a very interesting study by from a paper on IDC Digital Universe, which is published by EMC. So here they talk about how data is growing exponentially. So somebody might think where all this data is coming from. So let's take an example. A typical user might have a desktop, he might have a laptop, or some handheld mobile device, let's say iPhone, iPad. All these are being hooked to internet. So just imagine a one user using multiple devices all being hooked to the internet. How much data only a single user is generating? Okay, so let's say I'm some social media company, right? So let's say I'm a Facebook, or let's say I'm a Yahoo. I'm working with a company for a company Yahoo. So I need to understand what my users are doing. So I need to be able to distinguish, okay, this particular user is the same user, but he is coming from mobile, he is coming from a desktop, or he is coming from a handheld device, let's say. And even in hand devices there will be a lot of choices, right? He might be coming from an Android based platform, right? He might be coming from an let's say an iPhone. So the variety of data which is coming in and enormity of the data which is coming is exponentially growing. So there are a lot of challenges which we need to take care of, complexities which we need to take care of. The number of servers worldwide, they are growing at a very rapid rate because you need to scale out to meet the demands, right? The number of files in a data center, they are also growing at a very rapid pace. So here now the size is not just about terabyte or petabyte, right? Much beyond that, exabytes and zettabytes. Okay, so what companies, right? Because when we say a lot of people are jumping into big data, so what happens is, let's say I'm a startup. I want to do a startup and develop some product for the market. So how will I know whether this particular product will be successful or whether this product is needed in the market or not, right? So it's very easy for, let's say, a very big companies to do a market survey or do a feasibility study. But what will happen in the case of smaller companies, right? They will not have access to that many resources. It's not just about money, but it's also the kind of a goodwill in the market and access to resources. So there are companies like, let's say, McKinsey, Gartner, which do this on your behalf. For example, let's say a company like Gartner. So they kind of do a feasibility study. They study the market and see what is the product which is required in the market. And they will come up with suggestions. Let's say I'm a startup. I approach Gartner and say that, okay, I want to develop a product and this is my product. So what do you think, will it be feasible, or give me a kind of a statistics what is currently the market demand. So what these surprisingly, or I should not say surprisingly, what all these companies have come up with is, in the current market scenario, is they're saying that big data analytics is the way to go, because there will be lot of customers and lot of service providers, right? So all will have access to same kind of data, right? So let's say I'm a e-commerce vendor. I'm selling some products, and there might be a lot of competitors for me who are doing the same thing and selling the same kind of products, right? And both have access to same kind of data, but the difference will be how quickly you gather that data and process that data. So that will decide the competition. So you need to prioritize the big data projects, right, that might benefit from Hadoop. So the companies which will be leaders will be the one who will be able to quickly capture the data and process that data. So that's the current market studies, right? So this is also kind of a typical, a very close explanation to what somebody was asking, that how it is practically related to the current market. So it might not always be true that you need Hadoop in your organization, right? So it will depend upon the type of data, input data you have, type of output data you have, and also the size of data, right? It's not always cheap. Like the common misconception is, we will come to that in a few slides, that Hadoop can run on commodity hardware, so our cost will be very less. But that might not be the case, because there is a lot of cost involved, right? Cost might be of, let's say, having Hadoop admins in an organization who can understand how the Hadoop works, right? That is also a cost. A lot of factors goes into that. So some of the main Hadoop users, right? Nowadays there are a lot of Hadoop users, but in this slide we are talking about the users which are from different domains. Let's say Facebook and Yahoo, they are from a different internet space. Morgan Stanley is more of into finance. Amazon is again into e-commerce, right? So Rackspace is into hosting. So there are different kind of companies which are into Hadoop. So the interesting thing about companies like, let's say, Facebook and Yahoo is, Facebook is currently running a cluster which has the biggest amount of data, but company like Yahoo, they have currently the biggest set of cluster which they are running on the planet, with one cluster consisting of around 4,300 odd nodes in one single Hadoop cluster. So these companies, they are kind of pushing or driving the motivation for people to move into Hadoop, because when they say, okay, we can run this Hadoop platform in such a distributed way with so much of data on it and with so much of scalability, so it's very easy to scale out, right? Because you need some benchmarking for the other companies to step in, right? So all these companies are into Hadoop. Whether they provide, let's say, they are open to public domain or not, it's entirely different. Let's say Rackspace provide hosting, but Facebook is using Hadoop for a different purpose. So some user or somebody in the audience might ask, what Facebook might need Hadoop for, right? Obviously we talk about there are so many users, but just imagine the complexity of data which Facebook might have. For an end user, I may just simply go and click like, right? But what goes at the back end, right? There's a simple, very small byte call which might be happening, which when I click a like. But how that filtering is done, because one particular user might have 100 friends. Out of 100 friends, he might have filtered and grouped it, saying, okay, these particular users, the update should go, and these particular users update should not go, right? So only one single click, how much data and filtering it is generating. So you need a platform which can deal with such a large scale of data, because this might be true for all the users in Facebook, because there is an entire hierarchy or a tree. One X user might be connected to Y user, and Y might be connected to Z. So how you advertise the update from Z to X, right? All those things comes into play, right? So even a very simple event, actually if you look into the details of Facebook, there will be an AJAX call which happens when a like is clicked, right? And then it goes, it doesn't directly go into a DB, then it goes into their NoSQL pathway, and then they distribute it and filter it. So all these platform, it runs on Hadoop. So it's very important to understand how different use cases we might have for Hadoop. So this is a typical example. This slide is little bit old with the data. It is talking about how you set up a Hadoop cluster, or what are its requirements. So let's take an example from LinkedIn, for example. So in a organization, there will never be only one single Hadoop cluster, or there will not be only one single grid. There will be distributed grids. There will be more than one grid which will be having different set of resources, right? Let's say one particular grid which has 1,000 nodes might have more CPUs, might have more RAM, right? And another might have a different kind of setup. So within an organization, there might be a department like say R&D department, there might be finance, and there might be, let's say, a front page data which needs to be collected. So all these three data, they might have altogether 3 different grids, right? So how the scalability works in that cases, right? So this slide is basically talking about the heterogeneous environment you can have from a hardware point of view. Within one particular grid, you will try to keep the hardware everything same, but your 3 different grids within an organization may entirely run on 3 different set of configurations. So here the example is, in a one typical grid, LinkedIn has around 800 servers with 2 into 4 cores and 24 gigabytes of RAM. So we'll look all into detail, like what do you mean by when we say 2 into 4 cores, and why we need 6 into 2 terabyte rather than having a 12 terabyte drive, right, in one node. So it all has to do with performance, right? So the more distribution we do, obviously things might become complex or out of hand if we distribute things heavily, right? But the most important thing here is we need to understand that distributing data will have a trade-off between the complexity and performance, right? So we will look at that. So here they're talking about a typical case will be, we will have multi-cores. Multi-cores means more the number of threads, more parallelism you can have. Similarly, instead of having one single disk drive, you will have more than one disk drive in a server, so that you can have a parallel read and fetch from your hard drives because of the parallelism between the headers of the disk drive and more number of spindles you have, right? So this is talking about that. In another case, a smaller company might have a let's say a 30 node cluster in the case of a rack space, right? So it will depend entirely upon the organization's need, what will be your setup. And one thing you will notice is RAM also plays an important role in all the infrastructure and environments which we will talk. So we will look up all this when we set up cluster, what are the requirements and all that. But you will come to know that RAM plays a very important role, because your entire metadata resides in the RAM for the master node. So you will see that RAM is very important, and RAM actually decides what will be the size of your cluster, right? So we will look at that into details. So let's get started with the real thing, Hadoop, because up till now what we have talked about is building up a little bit of background that why we need Hadoop. So the first of all, what is Hadoop? So Hadoop is not a tool, first of all. It's not a single tool. It's kind of a framework which provides you lot of things, right? For distributing processing of large data sets across clusters of commodity computers. So when I say commodity computers, do not think that they are your desktops. Do not think that in a real production environment you will have a typical desktop kind of a node where you will have, let's say, single core or running with, let's say, 4 gigabytes of RAM, or running a hard drive, simple hard drive with 7200 RPM, right? So when I say commodity computers here in the case of Hadoop, it means they are non-enterprise class servers, right? We do not need that big dome servers, right? GS1280s and all that to run our Hadoop cluster. We can easily scale them out by using carrier grade hardware, right? We called it as CARRIER, carrier grade hardware, right? So all these details when we look into when we talk about cluster planning, what are the hardware requirements, what is hardware and all that. But it is for the time being, because this is the very first class. So when somebody says commodity hardware, Hadoop can run in commodity hardware, do not think that commodity means any box which you can pick from your home and keep into Hadoop cluster, right? It will, obviously it will work, but it will be a bottleneck in your Hadoop cluster. It is an open source data management with scale out storage and distributed processing. So what is the main advantage of Hadoop is, first of all, okay, it is open source. Another important thing is it is a scale out kind of a framework. It means that it is horizontal scaling. So can somebody quickly tell me, like, we have two kinds of scaling, right? Vertical scaling and horizontal scaling. So what is the difference between vertical and horizontal scaling? Can somebody quickly give me short descriptions or short line? What does it mean? What does we mean when we say, let's say, horizontal scaling or vertical scaling? What is the main difference between these two kind of scalings? Okay. Will is saying vertical add to the cluster same commodity computer. Okay. Janardhan, do you need to? You pinged me. Do you have any question, or you are just checking whether this chat is working for you or not? Okay, Will is saying vertical add to cluster. Okay. Shamek is saying horizontal means doing the same things with more resources. Vertical adding rich features on top of existing things. Okay, good one. Okay, fine. Janardhan is saying he was just checking his net connectivity. Okay, fine. I thought you had some question for me. Fine. Hi, good morning, Shrikant. I think you just joined. Okay, Madhu is saying vertical means scaling up. Okay. And Madhu is saying horizontal means scaling out. Okay, fine. Good enough answers. So let me kind of summarize what does vertical and horizontal scaling mean. So vertical scaling means, let's say in simple terms, obviously it will depend on different layers. You might have network switches and all that, but let's say keeping things simple, I have one server which is currently, let's say, running with 2 cores and let's say 4 gigabytes of RAM. What I can do is, how I can increase the power of that box. One is I can add more resources to the same box. So I will, instead of 2 cores, let's say I make the processor 4 core. Instead of 4 gigabytes, I make it 8 gigabytes. Right? So this is kind of vertical scaling. Horizontal scaling means I add one more node. Right? Instead of adding things on the existing box, I add one more box with 2 cores and 4 gigabytes RAM, right? So the total RAM in your cluster, in your distributed environment, is still the same, right? Whether I do vertical scaling or horizontal scaling. But there will be a lot of other limitations which will come into picture in the case of vertical scaling. Obviously, you cannot scale beyond a certain point, right? Let's say I cannot go beyond, let's say, a typical Intel architecture, 64-bit architecture. Let's say I want to have a total 1 terabyte RAM in my distributed cluster. It is not feasible to put that much on one box. Cost also comes into picture. But there will be a lot of bottlenecks. Bottlenecks will be at the layer of, let's say, network layer. Although your CPU might be really working really very well, your RAM might be sufficient, but bottleneck might be at your network level. Right? Obviously, network will also not be a single NIC card. There will be concept of teaming and all that, which we will look at. Teaming means you team up more than one NIC card to work as one. All those things will be there, but still there is a limitation how much we can scale it up. So the easier and the simpler way and cost-effective way is we add one more node into that. So this is called as horizontal scaling. So the concept of Hadoop is how quickly you can scale it out. Tomorrow, if my requirements increase, what I will do simply, I will take one more node and add to the cluster. Instead of shutting down my node and upgrading the same node up, what I will do is, without any downtime, I will add one more node and I will have a distributed framework. So this is horizontal scaling. So it's very important to remember, Hadoop is horizontal scaling, and commodity hardware do not mean off-the-shelf hardware. So the key characteristics of Hadoop, when Hadoop came into picture, what was the key things which were considered? First thing is it should be reliable, right? When we say reliable, when obviously we are not putting, let's say, a server which is having, let's say, dual power supply, right? It will be only one node, master node, but for the time being, in a Hadoop cluster, our main purpose was to scale it as quickly as possible and keeping the cost minimum. So we will not have that enterprise servers which will come with, let's say, a redundant power supply and all that. But how we will maintain reliability in the case of Hadoop? We will maintain, so there's a concept called replication, which Hadoop does. By default, the replication is 3 in the case of Hadoop. So whenever you copy a block to the HDFS, which is Hadoop Distributed File System, all these details you will see. So for the time being, you can think there's a file system which Hadoop uses. So by default, it makes 3 copies of all the block which you copy to it. So it provides you reliability by default by the framework, right? Because there are very high chances of one node going down. If you're running a cluster with 40 to 100 nodes, right? Chances of one node going down is very high. Other is economical, because we are using kind of middle level hardware, so it will be economical, and it is also very easy to scale. As I was telling you, you do not need to bring down your cluster, shut down any machine. You can simply add one more node. and it is also very flexible. Flexible means you can have different kind of machines or processing power units within the cluster, and we will see how it will impact. Or in our typical production environment where we crunch large amount of data, the recommendation is that all your nodes should run with the similar kind of configuration, similar amount of memory and similar processors, right? Otherwise, if one node has more power than the other one, there will be kind of an imbalance. But its flexibility is there. You can run with different set of hardwares and different set of configurations. So how Hadoop came into picture, right? So we have seen, we are saying Hadoop, but how Hadoop came into picture? Okay, so Shrikant is have a question here. So Shrikant is saying, flexible, can we say here we have some options, Pig, Hive, and etc. So actually, not exactly that, because those are frameworks which you can run with them. But obviously that is also a positive point of Hadoop, that when we say Hadoop is a framework, you can take a lot of other things and kind of interface with Hadoop. For example, in MapReduce 2, which is a newer version of Hadoop 2, you do not need to only run MapReduce on it. You can run even MPI stack on that, right? So a lot of flexibilities are there. And yes, you can say that Pig, Hive, HBase, a lot of things you can run in that framework. So that's why it's very flexible, because each organization can have its own use case depending upon the type of data they have. Some might prefer, let's say, MongoDB, right? Another might prefer, let's say, Cassandra, and some might prefer HBase, right? So it all depends. It provides you a flexibility of having interface to different things. Okay, so let's see how Hadoop came into picture. So Hadoop actually is not a very old thing, right? So there was a project called Nutch, which was kind of undertaken by Doug Cutting and Mike Caffarella, and they were working on Nutch. So initially their concept was more similar to the MPI stack, which is multiprocessing interface for parallel computing. It was more similar to that. But during that time, Google came out with two papers. One was on GFS and another was MapReduce. GFS is Google File System, which is the storage layer, and MapReduce is the programming framework, right? Although the concept of MapReduce is not new. If you go into linear programming, linear mathematics, and linear algebra and all that, all these functions, the MapReduce functions, have been there into linear algebra and all for a very long time. But bringing MapReduce into computing world was not there. People were not comfortable using that complex mathematical, arithmetical functions into the programming world. So when Hadoop came out, when Google came out with these two papers, obviously they did not publish the code. They only published the concept, right? What will be the concept? So that concept was taken by Doug Cutting, and he rewrote his entire project by adding a DFS to it, right? So he cannot use the word GFS because it's kind of Google file system. So he used the name DFS, Distributed File System, right? So which can work as a kind of a cluster file system, right? So when we look deep into that cluster file system, there is concept of locking, a lot of things come into picture, but it is not exactly that. We will see that DFS is a file system which sits on top of your existing native file systems, right? So what he did was he added support for DFS and MapReduce to his project, which is Nutch. And around 2006, Doug Cutting was hired by Yahoo, And that was the kind of an initiative or boost, which you can call it catalyst, right? It acted as a catalyst for the Hadoop product. And this nudge name was dropped off, and it came into a project, full-spun project called Hadoop, when Yahoo got involved into it, because it's very difficult for one guy to scale that project into such a large extent. So when Yahoo came into picture, they provided its own infrastructure, so to test out, provided a lot of resources, dedicated resources to work on it and scale it out. And what Yahoo did was, the best thing, beautiful thing was, Yahoo contributed it back under the Apache Foundation license, so that the community can work on it and contribute to it and develop it as quickly as possible. So in the meanwhile, there were some companies who were kind of doing benchmarking and try to understand, okay, what this distributed framework is. Because prior to this Hadoop concept of distributed framework, I'm not sure how many of you have seen the typical parallel computing, distributed computing setup. What will happen in that, you will have a dedicated lines, dedicated cables which will go between the nodes. It will be similar to a serial interface, right? The COM port, right? Nowadays systems, present day system even do not come with COM ports, right? There used to be a COM1, COM2 ports, right? So there will be cable which will be going directly from COM ports, and network traffic will go on the Ethernet, but this cluster traffic will go on that, right? So you will set up that typical MPI cluster, and you will have the concepts of stubs, the clients. When you fire a job, the job gets distributed and goes to each node in parallel, gets computed, and the result comes back. So, but that kind of setup was very expensive, and there were a lot of scalability issues, because you need to physically connect all the nodes together, right? You will find that kind of in universities, still in universities. So what happened was, New York Times came up with a benchmarking saying, okay, that they did processing of about 4 terabytes of image archive on a 100 node cluster, right? And Yahoo also did some tests and benchmarking. So around in about 3.5 minutes, they did a faster start of 1 terabyte of data. So when all these benchmarking started coming into the market, right, people got more interested into Hadoop. They say, okay, why invest time in something which is proprietary, right? Because when you are running a parallel computing framework, there were lot of restrictions that you need to have the same kind of hardware, and you go for a typical lock-in into a vendor, right? You have to have particular cable lengths, right? I was talking about the serial cable. There were a lot of hardware limitations on that. So all these companies, right, they can now experiment with the minimum investment. So because of all this benchmarking coming into market, people got interested into it, right? They thought, okay, like, why not give it a try, whether it can solve our use case or not, or not, right? And when all this started happening, more and more people started getting interested into Hadoop. And there was a company founded during that time, which forked out of the Apache Hadoop distribution. They took that and kind of customized it. The company is Cloudera. Obviously, there's another company, Hortonwork, also, which came in, but it came in much later. So the company Cloudera, when it was founded, so what they did was they took the Apache foundation of Hadoop, and they kind of fine-tuned it. Because what happens is, how typical MNCs or organizations, they will move to Hadoop. It was easy for, let's say, companies like Yahoo, because they were the ones who started with Hadoop, or companies like, let's say, Google. It was easy for them because they had that distributed framework with them, and they had the resources, the engineers to scale it out. But let's say a typical company which is not aware about what is distributed computing, to make things easier for them to deploy, you need some vendors, right, who can give you a kind of a ready-made solution and support, right? So companies like Cloudera, Hortonworks played a very important role in that. And another very important thing which was the Hadoop summits. The first summit happened around 2009. So people started attending summits. So on summits, there were a lot of presentations given that how you will scale out, whatever the challenges being faced, and so it kind of involved people into the development of Hadoop, right? So this was a very important landmark in the space of or in the history of Hadoop. Hortonworks, now you have a lot of companies, Hortonworks, MapR or MapR, some people call, right? A lot of companies who are into Hadoop, or they provide their Hadoop versions. So now look at, when we say Hadoop, it's not a tool, right? So what it is, it will be a combination of lot of things, right? When we say flexible, as I think, let me recall who was Shrikant, I think it was. Yes, Shrikant. He was saying flexible, right? He was giving me saying that flexible also means you can add, plug in different things. So when you say Hadoop ecosystem, what it is? So we need something which can feed data into Hadoop. For the time being, Apache Uzi is similar to a cron job. On a typical Linux system, you will have a cron job which you will configure to run at a particular time and do certain set of tasks. But what Uzi does, in addition to running jobs time-based, it also runs based on particular statuses. Let's say I may say run job A when job B completes, or when this particular file is there. So Uzi is kind of a job coordinator. Uzi is a job coordinator. You can think, we'll see Uzi in detail, but for the simplicity, you can assume it's kind of a cron for the Hadoop platform. It does, in addition to time-based scheduling, it also does scheduling based on the status. Status could be, you may say, okay, if job A fails, do this, or when this particular file is in this particular directory, do this, right? So it's more of okay, I have a question here. So Janardhan is asking where Apache comes into picture. I think you are talking about this slide, right? See, Apache is a foundation, right? Like we have a lot of projects which go under Apache umbrella. So when Yahoo started development on Hadoop, right? So it was given back to the community around the very early part of 2007. It was given as an open source project under the Apache foundation, Apache license, distribution license. Okay, so Uzi is the kind of a cron for Hadoop. Another system is we can have Hive. Hive is data warehousing system. Hive is a kind of a data warehousing system for the Hadoop platform or the Hadoop client, right? So in rather than having the traditional okay, who Janardhan is asking who owned Apache. No, see, Apache, okay, do not confuse when I say Apache, do not think Apache is only most common thing when people say Apache, they refer to a web server. Apache is a foundation. Okay, the question from Janardhan is, who owned Apache? Apache is an open community, it's a foundation, right? You have lot of incubations and lot of projects which go under Apache, right? Which gets the community involved into it and developed. It's not owned by any one user or company and all that. It's a foundation. Okay, you're most welcome, Jonathan. Shamik has a question here. She's saying, wouldn't Uzi be like a shell script which runs regularly in cron, but within that it will call in several scripts that would be processed based on certain criteria? Yes, absolutely correct. So Uzi is actually a workflow, a DAG we called it as. So when you write Uzi, you will write an XML file, right? So where you will give the job properties and a lot of things, right? And you will give it the workflow that this is the workflow it should run with. So end of the day, it's a script. Script means it's an XML file where you specify the tags and all that, what it should do. Okay, so coming back to this slide. So Hive is a kind of a data warehousing system. Pig-Latin is a kind of a data analysis. So what happens is, let's say we are system admins, right, or Hadoop admins. So it will not be easy for us to write a native Java code. So anyway, the Hadoop is written in Java, right? So anything, if you are able to write in, let's say, in native code, which is Java, will have a better performance, slightly better performance than any of the other frameworks or tools you use on Hadoop. So what is Pig-Latin? So it is kind of a data analysis, or you can say it's a programming language. What it does is, for someone who is not typically a Java programmer, who might not be able to write a complex code, can use Pig to run the MapReduce job on Hadoop. So the syntax is very similar to Erlang. Erlang programming language. So what you can say is, you can say, okay, load this particular file, group by, right, and output this, right? So you can write a very simple program in just 2-3 lines, which in Java might take a very huge effort, right? So also there are two factors which will decide Hadoop. Obviously you cannot write everything into Pig. One is the complexity, how complex your logic is. So depending upon, you will go whether this can be done in Pig or not. You will go for, let's say, a native Java. And also it will be time saving. Let's say you want to do a typical system admin work. Let's say you want to process a log quickly. You want to load an Apache log and you want to pass that log on, let's say, on tab. So you do not need to write your entire Java code and compile it and run as a MapReduce. You can simply run a Pig-Latin. So it will, you can simply, there's a concept of stores in Pig, right? You will give Oka store separated by, let's say, tab, and you will upload the data. We'll look into Pig and all that into detail. I will give you Miftah is saying it is like .ksh. Are you referring to Pig-Latin .ksh, or what you are saying? Or you are referring to that Uzi, it is similar to .ksh? See, K-shell, okay, see what happens is on a typical Unix, right? Nowadays when we say Unix and Linux, it means the same. But if you go to a typical the Unix word, right, where you have Sun Solaris and SCO Unix and all that, so the default shell used to be Con or the K shell, right, later on. In Linux-based systems, the default shell is nowadays Bash, right? So it is a shell, right? So this is not exactly a shell, right? This is not a shell, but what you can say is it does a lot more than that, right? because shell has a lot of intricacies, right? It is kind of a layer which sits between the kernel and provides a kind of a window to the user. But this pig Latin, you need your OS, right? You cannot write pig Latin directly sit on the kernel, right? So exactly it is not similar to the shell, but if you think logically, yes, it is doing kind of a, it is, pig is also when you, let's say when you invoke pig, let's say pig-x local, right? So it drops you to a shell, pig shell, right? But it does not mean that it is sitting right on top of the kernel, right? So those differences are there, but yeah, concept-wise, it is similar to a shell. Okay, so we will look into examples of pig and all. So for the time being, you can think that pig is designed to ease out the work of system admins who might not find comfortable to write Java code to do a particular job or a task. Okay, Shamik has a question here. He's asking, just like Hadoop has business case to be made, would know the business justifications behind all these tools around Hadoop ecosystem. There seems to be just too many. Like, what do these tools do from an end user perspective? Absolutely right. See, what happens is, if you, as we go along the course, when you will see, like you have set up a Hadoop cluster. So, okay, let me rephrase or in short ask what Shamik is trying to ask. So Shamik is trying to ask, what will be the use case or business case for using all these tools? So when we set up a Hadoop cluster, let's say I have a Hadoop cluster running, the Hadoop cluster itself is not the thing which will be doing your work. It is providing you kind of a file system, a storage, and it's a framework on which you can run a lot of tools, right? You can run MapReduce. So how you will run MapReduce? Whether you will write the native Java code or you will use some third-party tool, right? Or how you will pull or push or what we say load data into that framework, Hadoop, right? So all these, for all these things, you need tools, right? So a typical case could be, let's say here we are talking about Flume and Scoop, right? So I will come to that Flume and Scoop. So let me just complete what Mahout is. For example, coming to your point, right? What this could be. So already we have a lot of machine learning algorithms, a lot of algorithm into linear algebra, which are already there in place. So there is no point in rewriting or reinventing the wheel. So what is the best thing to do? Just write a wrapper around it and make it kind of compatible with Hadoop. So what this Mahout does is, it's a machine learning. It provides all the machine learning algorithms which are in place. What it does is it simply writes a wrapper around it so that you can run it on this Hadoop ecosystem, right? So similarly, you might have other things. Let's say HBase. HBase is a database, Hadoop database, right? So you cannot have a typical old kind of an RDBMS kind of a database. Here it's more of a NoSQL kind of an DB which sits inside the Hadoop, and you will have at the lower layer a file system which will be Hadoop Distributed File System, for example, in the case of Hadoop. So when we say HDFS, this file system will sit on top of your existing file system. Let's say what you will run at the native at the OS is, you might run Ubuntu, you might run Windows, or you might run, let's say, CentOS, or you might run RHEL. Whatever you run, you will use a native file system on the hard drive, which will be ext3, ext4. This HDFS sits as a pseudo file system on top of your existing file system, right? So that you can visualize the entire distributed space across different nodes as one. So a typical use case could be, as he was asking, could be Flume and Scoop. So what is Flume and Scoop? So as I was saying you, Hadoop by itself, setting up a Hadoop cluster, let's say I set up 1000 node Hadoop cluster by itself has no meaning, right? I should be able to use that cluster. Let's say, for example, operating system by itself, right? Operating system, how you will make operating system useful? Let's say I install a Linux kernel. What you will do on a Linux kernel? You need to have some applications or something which can interact and use the power of Linux, right? So you need to have applications on top of that, right? So similarly, Hadoop by itself provides you storage and the framework, the MapReduce or the processing framework, which you need to kind of utilize so that you can do your tasks. So example could be, let's say I have MySQL or an Oracle DB running and I want to do a processing on a large data set, right? I want to do a processing on a large data set. So what you will do is you can use Scoop to import and export data to Hadoop. So Scoop means simply you scoop a data from your RDBMS, load into Hadoop, do processing and load it back, export it to let's say a simple text file or a RDBMS, right? Similarly, you might have unstructured or semi-structured data, right? So what could be the okay, sure, Shrikant, I will come to that. Okay, I will come to Janardhan to that question as well. So typical tools could be Flume and Scoop. So, but what is the difference between these two is we might have structured or semi-structured or unstructured data. What could be the best examples of semi-structured and unstructured data? Can somebody give me an example of unstructured and semi-structured data? Okay. Santosh is saying phone calls, unstructured. Chat log, okay. Badri is saying chat log. Shrikant is saying web log. Okay, fine. Twitter data, okay. Web log, okay, fine. So pretty good enough. So unstructured data could be, best example is logs. It could be Apache logs, your chat logs. All these are unstructured data. So semi-structured, best example of semi-structured data would be, okay, yeah, Shrikant is saying videos and images are also unstructured data, right? So all these are unstructured data. So semi-structured data, the best example is XML, for example, right? So when you have to deal with unstructured and semi-structured data, you have a tool called Flume, for example, right? So what Flume does is typical production example. Let's say you have your server farm, which are Apache web servers, and they are generating logs /var/log, and there's some directory. You create, let's say, Apache directory you create, and your Apache server is writing all the logs to that directory, and you have that access error logs being written there. So you want to process that log automatically. So what you will do is you will configure Flume, and you point your Flume to read everything which is written in that directory /var/log/Apache. So whenever a log is written or modified, it automatically pulls into Hadoop and processes it according to whatever logic you want, right? So this will be the use case for the tools. So now coming back to the questions which I had, one question was Mahout. So Mahout is what Mahout is, so you have lot of machine learning algorithms already in place. Let's say a linear algebra, for example, you might have a algorithm for that, right? Or some machine learning algorithm for, let's say, artificial intelligence, right? Or neural networks, right? So there are a lot of, because Hadoop is quite recent, at the max last 7-8 years, right? But prior to that, there has been lot of systems in place, a lot of algorithms already in place, a lot of machine learning stuff in place, right? As I was giving example, artificial intelligence, neural network. So how you make that work with Hadoop? So you need kind of an interface where you can use the already existing stuff on Hadoop. So there's no point in, let's say, rewriting your machine learning logics or machine learning algorithm. So what Mahout does is it provides a wrapper around it so that you can use your traditional machine learning concepts and algorithms and all that onto Hadoop, right? So it provides kind of an interface. Now coming to the another part. Okay, so Shrikant is asking, I'm sorry, how can XML come under semi-structure? Because every language has XMLs and can be read just like flat files. No, absolutely right. Say they can be read like flat files, but when we say semi-structure, so XML you cannot write it anyway, right? Right. So obviously you can treat them as a simple text file, but there's some structure as well involved to an XML file, right? You cannot write anything because this concept of tags, closing tags, open tags and all that, right? So you have to have some kind of a structure as well in that. Okay, so coming back to another question I had was what is the typical OS you will use in case of Hadoop? So all the companies, they will use Linux. So when I say Linux, it will be, let's say, CentOS or Red Hat, RHEL. But it does not mean it cannot run on other Linux flavors. You can run it on Ubuntu. You can run it on, let's say, Fedora, CentOS, any Debian versions. Why the companies go for, let's say, a question was typically what Yahoo is using, for example. So they are using RHEL. So why they go for it? Because of this support contracts they have with the companies. They will go with RHEL. But RHEL, Fedora, and CentOS, there's not much difference between, especially between CentOS and RHEL. You can use any. For your labs, some people prefer using Ubuntu because they feel much more comfortable with Ubuntu, right? Whatever you are using. So here, let me show you. So I'm here in my labs, which we'll be talking about, right? So we will be, I'm using CentOS, right? So you can use whatever flavor you want, right? I have one server Ubuntu as well. So because some students sometimes they ask, okay, how it will run in Ubuntu. See, the concept here is the Apache Hadoop. The main requirement for running it is you should have Java because it needs a JVM to run, right? It needs at the base a Java container to run. So wherever you can run Java, right, run successfully, install Java and run it, Hadoop will work. It works on Windows as well. But in a production environment, the question was in production environment, you will never run Hadoop on Windows. Why? Because there are already a lot of resource constraints when we talk about Windows. Because let's say, even if I go for Windows 2008 server, right, it might require minimum 4 gigs of RAM for itself to do anything. But in a typical Linux environment, you might run a data node with the entire data node with 4 gig of cluster. So you have another framework called Azure from Microsoft, right? It's similar to Hadoop, which is distributed platform which runs on Windows, right? But typically the companies and organizations, they will be using Linux because it scales very well and the operating system itself has the least footprint in terms of memory, right? The Linux, just imagine Linux runs in almost all devices nowadays, even a simple cell phone, a simple router at home. You can have a Linux kernel in very small drive, right? A very small place. Even watches nowadays have a Linux kernel. Okay, so whatever you are comfortable with, any flavor of Linux you can use. So let me give you an overview of what I will be using in that. So currently my base OS is Mac. I'm using Mac. So my base configuration is quite decent. I'm using 16 gigabytes of memory in my base Mac OS. I'm using MacBook Pro. But this is not the requirement. You might have a system with, let's say, 2 gig RAM or 4 gig RAM. So it's fine with that. In my case, I can run a lot of nodes at one time. But that is not a requirement for practicing lab. You can do everything on single node itself. But why I'm running so many nodes and all that is because I will be showing you when we go on hands-on, I will be showing you running everything, how to run the entire Hadoop cluster in one node, how it will actually run in production, right? How it will be distributed. Your main name node, your slave node, your job tracker, right? Okay, for the time being, forget about the words which I'm using, job tracker and all that. Each component in the Hadoop will run on a separate node, right? So I will show you distributed way as well. So what I'm using here is, I'm using Oracle VM Virtual Box Manager because this is the free utility. Or you can use VMware as well. I have VMware Fusion also. So I'm using VMware Fusion because I'm on Mac. You can use VMware Workstation or VMware Player. And you can use Oracle VM on any platform, Windows, whatever you are running. So in these machines, what I am running is, I am running CentOS 5.4 in each. 5.4 in each of the machines, right? So why I'm running 5.4 is because many students ask me that, okay, it's fine that 6 is the latest and all that, so it works fine with that, but what about the older version? So that's why I've chosen something in between. I've not gone very old, let's say with CentOS 4, but I have taken a kind of a distribution in between. So I'm using CentOS 5.4. So here, let me show you. As I was telling you, my machine has 16 gig RAM, so I can play around with more nodes, but that is not the requirement. So typical will be, let's say I might be running a name node, one node. I will give, let's say, 4 gig to each. But in your case, if 4 gig is the total memory, you can give 1 gig or 2 gig, less than that, right? So you can control it much better. Because if you have a Linux machine, right, the resource requirements for the base operating system will be very less. So you can play around with the memory more for your virtual machines. But in the case of Windows, typically you might run into problems. But that's also fine. One node running in Windows is fine. So I will be using CentOS on VirtualBox. So all these details, it's given here. Right, all this detail is given there, which talks typically about my lab setup. So let me quickly show you the lab setup, because you can do, there's no restriction, you can use whatever you want. So this is typical system admin stuff. So what I'm doing here is, I'm running one main node, which is nn1 cluster1.com. nn1 for here I have given name nn1 because it means name node, right? So what is name node? We will see that. But so that you are ready for the next classes, let me show you a little bit of the setup which I have done. So I have given some amount of RAM to the node. I have given, let's say, 2 cores. Okay. Then display doesn't matter. Storage I have given 2 drives, 2 hard drives, virtual hard drives. One is around 14 gigs plus and another is around 6 gigs plus. Okay, Shrikant has a question. Shrikant is asking, one should have same version of OS to be installed on all data nodes. See, when we are practicing lab, we can have different versions, doesn't matter. But in a typical production environment, you will have the same OS running. Otherwise, imagine you are a Hadoop admin in an organization, you have 1,000 nodes running, and 1,000 nodes have many of them have different flavors. So if some problem comes, the troubleshooting will be very difficult, whether that problem is because of the OS or the Java on top of that, or it is related to Hadoop, right? So you will try to have an homogeneous environment, but technically speaking, you can run different OS. Okay. Oh, Will is saying, can we take a 10-minute break? Okay, 10-minute. 10-minute I think will be too long, but quickly I think if we want, we can take a quick logical break. What do you say, guys? Because Will is saying, can we take a break of 10 minutes? But I think 10 minutes will be too much. But if somebody wants, we can take a quick break. Santosh is saying, I am using Mac, so I need to get VMware. No, see, and he's asking, do you provide Fusion? No, see, Fusion is a licensed version, right? So you can download and get for that. But here I'm using Mac, right? So I'm also currently I'm showing you the VirtualBox, which is a free utility, VMware VirtualBox. So the entire lab I can show you in VMware Fusion, because but the students will come with the same question. What about us? Do we need to buy VMware Fusion? So you can download free VMware version with a 30 days evaluation. You don't need to run any key. It runs for 30 days. But if you don't want to get into those hassles and all, simply run VirtualBox. It works very well. So I will show you everything, all the lab with a free tool, which is Oracle VM VirtualBox, which you can download from the Oracle site. Okay. Okay. So Santosh is saying, okay. Okay. Can we see in any of the other free VMwares? Okay. See, you can use parallels, for example. Shrikat is asking, can we see this name node, data node in any of the free VM player? See, VM player also you can use, but VM player has a restriction, right? You can only run the already configured images. You cannot install and all that, right, in VM player. So you can go for workstation, or you can use KVM in Linux or Zen, whatever virtualization platform you are comfortable with. It doesn't matter. Okay, I think Will was asking for a break, but I don't think anybody is willing for a break. Okay, I think quickly I will, Will or somebody wants to, I think he was asking for a break. So quickly I will give some minutes logical break. If somebody wants to go and grab a tea or coffee, can go in. In the meanwhile, I will answer the questions people have. So Janardhan is asking, do we have any step-by-step doc to refer to build simple Hadoop cluster on Windows XP? See, the docs which I was showing you in LMS, right? When you talk about Hadoop, right? When you say on a Windows XP as a base OS, right? You need better is to put a virtualization software on top of that. Put any of your virtualization software you're comfortable, VMware or VirtualBox. But if you're going to install it on a typical only on the Windows XP one, then doing your entire lab in the one Windows XP box will be very difficult. It will be very difficult to do the entire lab on the base Windows operating system, because you have to have a different environments, isolation, and a lot of things will come into picture. So best thing is whatever platform you use for your labs, whether Linux, Mac, Windows, whatever, put a virtualization software on top of that. It could be VMware, VirtualBox, Parallels, or KVM, Zen, whatever you are comfortable with. It doesn't matter. Okay, so I'm running different nodes. So let me show you typically here. So host name is nn1cluster1.com. I'm using two disk drives here, SDA1 and SDB1 in NN1 I was showing you. But it doesn't mean that you have to have exactly similar setup. It depends upon what you want to do. So here you see I have given 16 gigabytes of RAM. Why? 16 gigabytes of disk drive. Why? Because I have a local repo, so that whenever I do yum install, right, it doesn't go to internet. So everything I have copied locally, a local repo. So that's why I've given more space. But you do not need to do that. You might have, let's say, a CentOS CD or DVD, and whenever you need package, you might install from it. But in my case, to make things easier, I have created a local repo. Right? So the typical setup will be, it will be good if you have minimum 2 machines in virtual VM, so that you can do a distributed setup. You can see how it actually works in production. More than that, very good. But you can do all your labs on even single node. Right? So I will show you all this in our week 2. Week 2, which is tomorrow. So here you will see the another node, which is DN1, data node 1. I've given only 2 gigs of RAM. Here I've given 4 gigs of RAM. Right? So depending upon how much resources you have, you can give different kinds. All are running CentOS. So here I am sitting on my NN1. So if I do uname -a, I'm running 64-bit flavor, right? 64-bit version of my virtual machines, CentOS. And I have configured all this is system admin stuff. I've configured a DNS as well. This NN1, it's acting as a DNS server. So if I go and connect to a data node, which is on IP71, SSH root at the rate of 192.168.1.71, right? I do if config here. See, the IP is 71 and my server is running on, server means the name node, running on 70. So obviously we'll see all this in week 2, but just to get you ready so that you guys can play around if you want with your virtual environment. So what is the requirement? Obviously all the nodes, virtual machines which you practice with, they should be in the same subnet. So I have given 192.168.1.0 subnet /24, right? So my name node is 70, data node 1 will be 71, then data node 72, 73 and all that sequence. So in each of the data nodes, right, I have configured my DNS resolver to point to my main server, name node 1, which is 70. So all the name nodes, they query the NN1 for DNS, right? It's a simple typical admin stuff. So this is the zone I have configured. Right? I have configured a zone here, cluster 1, right? And I can show you this file also. So I think most people will be aware of from Linux background, they will be aware how to set up DNS and all that. So this is a typical DNS, right? But if let's say if somebody does not know how to set up DNS, obviously there are a lot of docs to refer, but if they do not want to use DNS for their labs, what they can do is they can simply make entries in /etc/host file. Simple. So I will show you all this tomorrow, which is our week 2. How? So this is my typical lab setup. I have a question here. Phil is asking, are there any links to download Oracle VM? Okay, no, it's a free utility. It's very simple, right? If you go here and find VirtualBox, right? Oracle VBox, right? You go the very first link search shows you. You just go here and download it. It does not ask you for any license, any account, anything, right? You just download it, whichever version you, base OS you want it for. Okay, another question from Shrikant is, do we have doc to set up DNS? See, in the doc which I have showed you, right, there's a setup to show DNS in this one, because this is talking about my infrastructure, right? So there will be doc. So, but for the convenience and the sake of other participants in the class, setting up DNS is not mandatory, right? But why I'm done all this is because this is the way how it will run in production. So I'm trying to show, I will try to show you the setup as close as possible to the production so that you will get an idea. So in real production, there will always be a DNS server setup and your clients will be querying it, right? So let's say I'm sitting on data node 1, and if I do ns lookup, let's say nn1.cluster1.com, right? So it says, it contacts the name server and tells me what is the IP. Similarly, any node, right? I may say dn1 here also, right? So it is telling me that it goes and contacts the server at 70 and it's telling me IP, right? So what is needed for Hadoop cluster to communicate to each other, right? In a Hadoop cluster, we might have, let's say, 10 nodes. So how the nodes communicate to each other? Obviously, at the lower level, they will be communicating with IP, and at the much more level, using MAC address at the Ethernet level. But they should, first of all, the condition is, obviously, they should be in the same network and they should be able to ping each other. That is the first requirement. Right? If I do 70, obviously, my node should be able to ping it, right? It should be able to communicate to it. Second is, how I will think, how I will use. Obviously, I can use all these IPs in the config file, but remembering IPs will be sometimes very difficult when we go beyond certain machines. So that's why we have given names. So when we will be talking about, let me show you quickly here as well. For the time being, forget about user Hadoop and all that. So JPS is a command. When we do Hadoop configuration and all that, I will show you. JPS is similar to a PS. PS is a Unix typical command, right? Process. You want to see process. So JPS is Java process command. So it will show you what Java processes are. Currently, you do not see any Java processes running. So if I want to start, let's say, Hadoop data node daemon, I have to start a data node. I will do start data node, right? So currently, you don't need to worry about what command I'm showing you. We will all cover all in detail, but I'm showing you the communication part. So if I say JPS, it's saying data node is up. So how this data node is communicating to NS1 on the name node, right? Let me start the name node here. Here we have started data node, right? So here on the first machine, let me start name node. Right? So name node is up here on this node. Now these two nodes, how they are communicating, okay, forget about the details of the config files and where all this, we will all cover in detail, but let me show you why DNS and communication is important. So on name data node 1, I'm telling where it should look for Hadoop, where it should look for Hadoop master, which is name node. So here I'm saying NN1. So instead of NN1, you can directly give the IP also, 192.168.1.70, if you do not want to configure DNS. But remembering IPs could be difficult. So that's why I'm running it quite similar how it will be in production, right? So then it goes and communicate, right? So you can see your cluster. If I do 192.168.1.70:50070, right? So you will be able to see your name node. Name node is up and all. So all these details, everything we will cover, right? So, but this is kind of heads up for you guys. Yeah, so Shrikant is asking here, I have changed port to 9000. So it doesn't matter what port you run at, right? So from a system admin point of view or a background, right? So what typically ports you can give? Obviously, you cannot give any port which is less than 1024, right? You cannot give 1023 or port 90 or 100. Why? Because you need root privileges to bind to that port, right? So you can give any port beyond that, right? So you have to remember that port, as simple as that. So you can give any port you want, which is a non-amphipherial port. Non-amphipherial ports are ports above 1024, which does not need root privileges to bind to it. Because whenever we run Hadoop, we will run Hadoop with a non-root user, right? So here I showed you, I changed to this user by doing su-Hadoop. So I'm running this as user Hadoop. So okay, for somebody who is not aware about Linux and all that, do not worry about all those things. We'll see all this detail, creating user, right? How we will extract Hadoop, how we will install Hadoop, how we set up configuration. We look all in detail, but I was referring to the question which he's asking, right? So you can give any port you want. Okay. So this will be the important part is they should be able to ping each other, and they should be able to communicate with each other by some easy name, because remembering IPs for all could be little tedious. Here we have only 6-7 nodes at the max, so we can use IPs, but it's always a good practice to go by naming convention. If you cannot set DNS, make entries directly into /etc host file, and they will be able to communicate and ping to each other. As simple as that, right? So let me show you quickly a Hadoop command also. DFS. So all these commands will be looking in detail. So this is talking about HDFS. So this file system, Hadoop file system, right? All this which we are talking here about, you will not see anywhere, right? I'm currently sitting in my PWD, present working directories of Hadoop user. If I do ls-l, you will not see any of these files there. They are on the HDFS file system. They are not an ext file system, right? My native file system will still be ext3 or ext4 or ext2, whatever you want to use. Obviously, we will not use ext2. We will use generating file system, ext3 or ext4, right? And on top of that, we will have an HDFS file system. All this we will cover in detail. Okay, so first thing for you guys will be after the very first today's session will be go and download whatever virtualization environment you are comfortable with. Download it. Obviously, the free versions will be preferred. Oracle VM VirtualBox is the best one. It runs very well, very easy to manage, and install a single virtual machine inside it, at least one node in a virtual machine, whether a Ubuntu, CentOS, Fedora, RHEL, doesn't matter, because so that we could be ready for our next class. So we will cover everything in detail. Okay, so now let's come back to the slides. Okay, so now let's see what actually Hadoop is. Hadoop has two very important parts. One is the storage unit and another is the processing unit. So what is storage? Storage is something you need to write data onto, which is HDFS. Right, the command I just showed you when I did Hadoop fs-ls, right? All these are Hadoop file system command, HDFS commands, right? It shows me the Hadoop file system. So this is the file system where actually our data will reside. At the lower level, it will be ext3, ext4, whatever at the base OS level. But from a Hadoop point of view, the file system will be HDFS. HDFS stands for Hadoop Distributed File System. It will be distributed across nodes and it will be natively redundant. So what does it mean is the HDFS file system by default is redundant. You do not need to configure RAID, right, which we configure in typical Linux systems. We do not need to configure RAID, either software RAID or hardware RAID, because by default Hadoop makes 3 copies of each block. Obviously that parameter is configurable, but by default if we do not configure any parameter and we install Hadoop, it makes 3 copies of each block which is written to the file system. So it is natively redundant. Name node is the master. So in a Hadoop cluster we have 2 important kind of machines. So Hadoop architecture is kind of a master-slave architecture. You have a master and you have the nodes which talk to it. They are called as slaves. So the master node in Hadoop is known as name node. So in this case I was showing you, and then one is name node 1, right? So this is our master node which will have the name node daemon running. All other nodes which has data node daemon running, right, they are the slave nodes. So when we talk about Hadoop storage, we talk about the file system which will be on across different data nodes. I may have data node 2, data node 3, data node 4. All will have their native file system ext3, but there will be a file system HDFS which will be laid across all the nodes, which is HDFS. So when I run the command HDFS fs-l, it does not bother where that file is coming from, whether it's coming from data node 1, data node 2, data node 3, doesn't matter, because that file system is laid uniformly across all the nodes. Obviously there are a lot of things, if one data node goes, how it fetches and all that, all the details we will look into. So the name node is the one which is the master, which keeps track of all the data blocks. So what does it mean? We'll come in detail to that in our next slide. Another important part of the Hadoop is the processing. Storage is provided by HDFS. The processing is provided by the MapReduce framework. We have a framework which is kind of the brain of your Hadoop, right? HDFS is the file system storage, but you need some brain which is this processing unit, which is MapReduce. It's a MapReduce framework. What it does is it splits whatever job you submit to Hadoop, it will split it according to the processors you have. Let's say in a Hadoop cluster you have 2 nodes, each node with 1 processor, right? So you can run 2 processes in parallel in a Hadoop cluster, right? Obviously we will not have only 2 nodes and each node with 1 processor. There will be different cores, but for the simplicity. Another very important thing how Hadoop differs from typical old distributed environment is there is a concept of locality of reference. In old environment, what used to happen was, let's say in an RDBMS or whatever, if you need to process or do some processing on a data, you will move data near to the processing, right? You will copy that data, or it will pull that data into RAM where that processing logic is running, and it will process it there. It is fine when you have small amount of data, but in the case of Hadoop, you will be talking in terms of terabytes or petabytes of data. So copying, moving data will take a lot of time, that large amount of data. So what is typically done in Hadoop is, instead of moving data to where the processing is, you move the processing to the node where data is, right? So let's say you copy a file and that file is on data node 1, right? So you will run your job on data node 1 so that it runs on the same node where data is. It's a best case scenario, right? Obviously, if that node is not free and has lot of data processing already running on that, it will go and schedule on some other node. All these details we will see. But the main difference is, instead of moving data to processing, you move processing where the data is. This is called near the data, right? This is called a locality of reference. So you move your logic, your processing to wherever your data resides, so that you avoid copying that data, that large data set, across the network. It is self-healing. So what does it mean, self-healing? Let's say you submit a job to Hadoop cluster. Typically what job means, let's say you want to do a word count on a file. When you submit a job to Hadoop cluster, and let's say it goes to data node 1, and data node 1 fails, right? Because let's say hardware failure or something, the job will not fail. It will automatically switch to another node and start processing there. So this is called self-healing. Obviously the time will increase now, right? Because let's say the job was to finish in 1 minute, and after, let's say, after 30 seconds of processing of the job, the node went down. So obviously that job has to shift to another data node and it has to start again. So the total time will execute, but you will not get a failure. The end user will not know that his job has failed. He will come to know that, okay, this job has taken a longer than before, but its job will be done. So it will be kind of a self-healing. Also, it will be in Hadoop, it will be aware of your bandwidth utilization. This is a concept called rack awareness, which we will see and configure in our demo in our labs. So when the name node, which is the master, when it tells to copy a file, right, or make a replica of blocks, when I say like the default replica is 3, so it doesn't make sense to copy the same block 3 times on the same data node, right? It doesn't make sense, because if data node goes down, your data is gone. So it will always copy on separate data nodes, but it does not mean that it will copy anywhere on the data nodes, right? Because what might happen in our production is, we might have one rack, right? And that rack has, let's say, 10 servers, right? And you copy data on 10 different servers within the same rack. What happens if rack goes down, right? Again, you have loss. So your Hadoop is also rack aware. So it will not make copies or replicas of the data within the same rack, so that if the rack goes down, you do not lose your entire data. Also, you can drill down to different levels. Even if you're, let's say, you have 3 racks in your data center, each rack, for the simplicity, has 4 data nodes. And rack 1 and rack 2, let's say they are behind the same switch, right? So it does not make sense to copy all your data on rack 1 and rack 2 only, because what happens if the switch goes down? Again, your entire data goes down, right? So all these concepts are there. So we will see how we configure and all that practically, all these things, rack awareness. So Naveen has a question here. So Naveen is asking, is it like name node redirects to data node and data node processes it? No. There's another component which is job tracker. We will come to that. For the time being, I'm just talking in terms of to give you an overview of the simplicity. Right? So this is the MapReduce, self-healing, cluster storage, and the jobs which you submit to is taken care by a job tracker. So here currently you see name node daemon. You have, what are the important daemons in a Hadoop cluster? You will have a name node daemon, which will be your master, and there will be a data node daemon, which will be your slave. But it will be master and slave for what? Master and slave for your storage unit, for your HDFS, right? For your file system, right? It will be master and slave for your file system. Similarly, there will be a master slave for your processing logic, for your brain, right, for the MapReduce. So master will be job tracker and slave will be task tracker, right? Name node and data nodes, they are master and slave for your HDFS. Job tracker and task tracker, they are master and slave for your MapReduce. So here I have started data node. I will start task tracker as well. So task tracker will be your slave. If I do JPS here, task tracker will be your slave for your MapReduce. And what will be your master? Job tracker. So I can run job tracker on the same node where I'm running name node. For the simplicity, here I'm just giving you, this is our very first class. So I will run it here only. But in an actual typical production environment, right? So your job tracker will always run on a separate node. Job tracker will always run on a separate node than your name node, so that name node is not heavily loaded. So we'll see what name node does. So then you will get an understanding. So there will be a master slave for each component. Okay, Shamik had a question. Sorry, Shamik, I think I missed on your. Shamik, what was your question? Let me scroll the screen up. Okay, Shamik had a question here, which I missed on. Is HDFS created per node or is per the entire cluster? HDFS is created for the entire cluster, right? This is what I was telling you. When we say HDFS, right, I may have data node 1, data node 2. Let me start a data node 2 as well. Let me log into data node 2. SSH root @192.168.1.72. This is my data node 2. Host name. This is data node 2. Your HDFS file system will be across your entire cluster. It will not be for only one particular node. At the underlying ext3 or whatever your native file system will be independent for each node, but your HDFS will be across your entire cluster. So when we create the HDFS, you will get a better understanding, which we will be covering tomorrow. There's a concept, right? As you format your native file system, right? You do mkfs ext3, let's say, on your hard drive. Similarly, you do a format for your HDFS. The very first time when you configure your cluster, you do a name node format. When you do a format for the very first time, the HDFS file system is created across the entire cluster, across the nodes you have. Okay. Okay, in the lab I have only started one data node. So Shrikant is asking, do you have many data nodes? But it's showing only one. So here for the simplicity, I have started only one data node, right? But I have a lot of data nodes here, right? I have a lot of data nodes. So I can run all these data nodes and they will all talk to cluster and to name node and build your namespace. Okay. So we will have two components here. One is, I was telling you, the storage. Storage has master and slave. Master is name node, slave is data node. Similarly, in the MapReduce, you will again have master and slave. Master is job tracker and slave is task tracker. So task tracker will run on each of your data nodes, and job tracker can run on the same machine where your name node is, or you can configure a separate dedicated machine for job tracker, which will be the typical case in your production, right? So it will depend upon how you. Yes. So Shrikant is asking, can we start all at once? Yes, we can do that. Here in the lab, I will be showing you both ways. right? Because in a typical production environment, when you have 1,000 nodes, it's not feasible for you to go to each node and start one node at a time. So there is a concept of start data node all in one go, or stop data node all in one go, right? We will look at that. But why I'm going you command one by one is you will understand in week 2, so that you get an idea of what each daemon does. If I do start-all.sh, it will bring the entire cluster up, and you will not know what each daemon is doing. Here I have task tracker and data node running, right? So to get a better understanding what each daemon does, right? We will see, we'll copy file, we will shut down data node daemon, and we will keep the name node daemon up. Then you will see what things you can do when particular daemon is running, right? So it is better for understanding. Okay. So let's look little bit deeper into name node and data node. So name node is the master of the system. It maintains and manages the blocks which are present on data nodes. So what does it mean? In a typical Linux system or a Windows system, whatever, you have a hard drive, you have a master boot record, which is called MBR, right? Then you have something called FAT, which is file allocation table, right? Which will have an inode structure, right? Which will say, okay, inode 1 maps to these blocks. Let's say you will have, let's say, file1.txt. That file will have particular inode, right? On pointer, inode number, right? And it will keep a block mapping of that, right? So that this particular file is mapped to block, so block 1, block 2, block 3, right? All these resides on a hard drive in a Linux system or a new Windows system. But what happens in the case of a Hadoop is your name node is the one which is the storehouse of your metadata. All right, that MVR which we are talking about, the concept, right, the pointer and the inode structure, right, it resides on your name node. The name node will be the one which will have your metadata. So let's say I have file1.txt. So the name node 1, which is the master, will have metadata. It will have a record which will say file1.txt. The permissions are this. This is the owner of this file, and this file resides on block 1, block 2, block 3, block 4. But where are block 1, block 2 and block 3? They will be actually on the data nodes. The actual data, the physical blocks, they reside on data nodes, right? Actual blocks, the actual data, right? They resides on data node, but its metadata resides in the name node. So whenever you query a file or write to a file, right, the name node is the one which is giving you a kind of a pointer. It's just inode structure, similar to an inode structure. So it says file1.txt is at these blocks. So you go and fetch these blocks. But where are those blocks? Those blocks are on data nodes, right? So how this is happening? There are a lot of details which we'll see that how this is happening. But for the sake of understanding in our week 1, what happens is when you bring up your cluster, when the data node comes up, it advertises all the blocks it has. Let's say I start data node 1. So when I say I start data node 1, it does not mean I start the physical box, right? The physical box is up, then I start the data node daemon on that, right? When I did when I did Hadoop -daemon start data node, it means I started the data node daemon on that. So when I start the data node daemon, right? So it means when the data node has come up, it advertises the blocks it has, right? It will say I have 1,000 blocks. It will advertise to the name node. So name node will build that map. Name node will say data node 1 has 1,000 blocks, block 1 to block 1,000. data node will advertise this block. So name node will say, okay, block 1001 to 2000 are on data node 2, right? So when you want to write a file to HDFS, you will contact name node. So name node will say, okay, your file will be, let's say, file.txt. It will be stored and it will automatically map at the backend at block 1, block 2, block 3, which will be actually sitting on your data node. So all these details, how it knows where each block is and all that, we will see. So the important point to understand here is your name node is the master, which is your metadata. So if your name node is not there, although your data will be there on your data nodes, but there will be no way to fetch it, right? Similar to on a typical hard drive, right? So when you write a file on a hard drive, the actual data is in the blocks, but if you remove that FAT, MBR, you have no way of accessing it. Similar to a delete operation, right? When you delete a file, what actually happens? It does not mean, unless and until you do a secure delete, right? So let's say I delete a file on a typical ext3 file system or a Windows NTFS or whatever file system you are using. So it doesn't mean actually your data has gone from the physical blocks of your hard drive. Actually the pointer which is pointing from your FAT, right, the inode structure to that block is gone, right? Data is still there. So similarly, name node is the metadata storehouse. It knows where each of your blocks are there for that particular file. So let me show you this example. We will be looking all this in detail, but for the sake of understanding. Okay, so let me, somebody was asking, you have only one data node. So let me start another data node also, 73. So you do not need to worry about here how we configured all this and all that. We'll all look in detail how we configure this. So I do start data node. To start data node. And let me stop task tracker, because task tracker is not what we need here currently, because we are talking only about the HDFS part. Right. So I've started data node on each of the nodes. Right. So if I do Hadoop DFS admin -report, right? All these commands for the time being you can ignore it. We will see all this in detail. So I'm just coming to show, giving you a kind of an window into what will come in your future lectures. So here if I run report command, it is showing me I have 3 data nodes with 71, 72, 73, because I have started data node daemons. So how name node came to know is when I started data daemons on each of the nodes, they started advertising their blocks. And there's a concept of heartbeat. Data node sends a heartbeat periodically, which is a configurable parameter, every 5 minutes to name node, right? It's a configure, you will configure. But let's say it sends heartbeat every 5 minutes to the name node saying, I am there, I am there. If name node doesn't get a heartbeat in that time, it will mark that data node as dead, right? So then you will not see it here. But now we have started all data node and my cluster is very small. It does not have much data. So it has quickly come in the name node and name node nodes. I have 3 data nodes, right? Now let's come to the point which I was showing you, metadata. So I was showing you, so this command which I have run here, right? Any command, right? Let's say fs, this command. This command doesn't mean that I have to run on name node. This command can be run anywhere in your cluster because your entire HDFS space is common. As somebody was asking, is it on one node or across all nodes? You can run all the commands anywhere in your Hadoop cluster, right? So we will see all this, right? So because your entire namespace is same. So let's say Okay, let's go to machine which has less amount of data, because otherwise it will confuse you. Okay, so let's say I'm sitting on node 2, I'm in my present working directory, and let me copy this file to Hadoop, right? So currently if you see, if I do HDFS hyphen ls, right? This is an ls for a Hadoop file system. So if I do ls on the Hadoop file system, currently you do not see any test file here, right? So let's copy this test file which we have in my local file system ext3 in my home directory to this. So command and all that you can forget, we'll see all that, but how we put that is I simply do test and I copy it. Right? Now if I do this file has gone to my HDFS. How you read that file is simply you can do all the same command, cat, whatever you do on your native file system, but you proceed that by Hadoop FS. And now I do cat here, so it is telling me the file is there, right? But now let's come to the point I was telling you. So now where this file has gone? This has gone in the HDFS file system, right? So I have 3 data nodes running, so it might go to any of the data nodes, right? It will be decided by name node. So all this detail we will see how it decide where it should go, right? So let's say I am here, my name node is up, right? I can do Hadoop fs-ls/test. I can do cat as well, right? I can do cat as well. Now let's go and start and let's go and stop data node daemons. So I say stop data node, right? So let's go and stop data node on each. So now I have stopped data node on each of the data nodes. I do not have data node running in my cluster anywhere. Janardhan is asking, is there any shared components between data nodes? No, not shared components, but we might have, let's say, an FS location where we might be, let's say, pulling all the configs and all that, but there will be nothing shared between data nodes, right? HDFS, the entire space is laid out across each of the nodes, right? So when HDFS file system is built, each data node will contribute its block to that, right? But it does not mean that one space of the HDFS which belongs to particular data node can be overridden by another data node, right? So it will not be shared, but HDFS as a whole is laid out across the entire. So let's say now I have stopped as data node daemon on each. So now let's do the commands again. I do ls. See, ls is working, but if I do cat, see, cat fails. Why? Because when I do ls, the name node knows about the metadata. I'm only asking, when I do ls, I'm only asking about the metadata. I'm not worried about the contents. I'm asking the metadata. So Hadoop name node is running. It is able to tell me that this file has these permissions, this is the owner, and this file is there. But when I'm trying to read and access that file, it is failing. Why? Because data nodes are not there, right? Data nodes are not there. So this is what the concept I was trying to explain you here. Right? So when the data node are not there, name node knows that there is this file which we show by ls, right? File is there, metadata is there. But when I'm trying to access this, so name node what is trying to do? It is trying to fetch the blocks from data nodes, but data nodes are not there. all these detail, configuration, everything. There are a lot of concepts here, how it knows and all that, we will see that. Okay, so another question from Miftah Ahmad is, he's asking, instead of going to each node one at a time, stop, can we do stop for all in one go? Yes, we can do. We'll see that. So there's a concept called master and slave files, right? Which will have listing of all your data nodes in a cluster. As I was telling you, in a real production environment, it will not be feasible for me when I have, let's say, 1000 nodes to go to each node and do stop, right? I can do stop all and start all. Or if I want to stop only data node, right, I can simply write a script and enable SSH private and public keys, so it does not prompt me for password. So from one node I can go and execute the command on each. So we will see all that. We can do in one command start, stop, data node daemon on all three, or on 1000 nodes, whatever we have. So this is the important thing to understand from this slide what we were discussing. So that name node is the master and data nodes are the slaves. If name node goes down, you will not have access to anything. If here the name node was running, if I stop the name node daemon, you will not be even able to do ls, anything, access the file, even when your data nodes are up, because this is the metadata house. And if you stop data nodes, you have the metadata, but you will not have the actual data, right? This is another very important part here in the Hadoop. Okay, so Madhu has one question here. He is asking, is there any requirement for minimum of number of data nodes, because you said Hadoop maintains 3 copies of each block? Okay, very good question. So we will see that in detail, but let me answer this. So let me repeat the question what Madhu is asking. Madhu is asking, is there any requirement for the minimum number of data nodes, because you said Hadoop maintains 3 copies of each block? So obviously if I kept a replication factor of 3, so minimum I should have 3 data nodes, right? Replication factor is 3, I should have minimum 3 data nodes, right? But replication factor is also configurable. So if I go to name node, Hadoop config HDFS, if I do, right? So replication factor I will only set 1 here in the lab, because mostly I will start only 1 data node, so my cluster should be able to run with 1 data node, right? But I should not set this value higher than the number of machines I have, right? So all these details are there. We'll see that. So up till now we have seen about the master node, which is name node. We have talked about little bit about the slave nodes, which are the data nodes. But there's another very important machine which is called a secondary name node. Although the name here is kind of a misnomer, the very first thing which comes to our mind is when we say secondary name node, the very first thing, if somebody is from a clustering background, he will think that this is a failover name node. That if the primary name node goes down, this is the name node which will come up and do the work of the primary name node. Actually, that's not the case. So secondary name node, what it does is, it is kind of a checkpointing machine. So what is checkpointing? Name node, our primary name node, right, which is NN1, is a single point of failure. So where it is storing its metadata. Okay, so all these detail configuration we have in our picture, but let me show you where it is storing our metadata. So this is all configurable where we want to store this metadata. So this is a directory I have given, /data/name node. Under that I have told it store your metadata. So what is the metadata? Metadata is FS image and edits file. So the very first time when you configure your Hadoop cluster and format your namespace, right, HDFS file system, it will come up with FS image, which will be empty. Your edits will be empty. When the name node starts, what it does is it loads the FS image into the memory, and whatever changes are done, they are written to edits file, right? Okay, all there's a very detailed discussion on this in our week 3 on this, but just to get you familiarized with what secondary name node is, there is an image called, there's a file called FS image, and there's a file called edits. So when the name node comes up, it will upload FS image into the memory, which will contain the metadata of your entire namespace, right? Entire namespace, right? But whatever changes you do, let's say you copy a file as we did, so those changes will be written to edits file. They will not be written to FS image files, whatever writes you do, right? So what happens is, these merging of edits and FS image will only happen when the name node comes up, right? So let's say if I want to merge whatever changes which has happened in edits file, I need to restart the name node daemon. So when the name node daemon comes up, it reads the edit files and merges it with FS image file and reloads a clean image of FS image and then empties the edits file, right? But this is not very practical in a production environment, because restarting name node daemon means outage, right? And also in a heavily loaded cluster, right? Let's say companies like Facebook and all, the edits file will be growing at a very rapid rate, and it might be very large. Let's say 12 terabytes or 20 terabytes, or sorry, 20 gigabytes, right? So merging 20 gigabytes of file into FS image might take a long time if you restart. So it means your outage time will increase. So this is not a typical right use case for your production. So how this is handled is, there's a secondary name node. The name is secondary name node. What it does is, it does not run any of your name node daemon. What it does is, it runs a daemon which is called secondary name node daemon, right? Secondary name node daemon. What it does is, it periodically goes and connects to the name node and takes a copy of this FS image and edits file and merges it on behalf of the primary name node. So how often it connects? It's a configurable parameter. By default, it is 1 hour. So every 1 hour, secondary name node will go to the name node and will fetch both FS image and edit files and merge it and copy it back to the name node. So it is doing that work on behalf of your primary name node, right? So also when it is fetching, it is obviously keeping a copy with itself, so that in case your name node, primary name node goes down, you can bring up your secondary name node as your primary name node. So it is not an automatic failover, right? You have to go to secondary name node and start your daemon up there. You have to start your name node daemon up there, right? And you have to change the IP as well of this secondary name node to be the IP or same IP as your primary name node, right? So in our case, our primary name node is running on secondary name node. Primary name node is running on IP 70.70, right? So let's say if I want to bring this secondary name node as my primary name node, I have to change its IP to .70. Why? Because the secondary name node, all my slaves are talking to .70 IP, right? So I cannot go on 1,000 of the slave nodes and tell them, okay, now your IP of the name node instead of 70 has changed to 71, right? So easier way for me is just change the IP of the secondary name node to be 70. So now your secondary name node starts taking blocks from your slave data nodes, right? So all these details are there, right, which we will see. But the point here from this slide is, the secondary name node is not a hot standby, right? Do not confuse it from a clustering point of view, from a typical Linux cluster, where if we have more than one node, it means that if first node fails, the secondary can serve the traffic. But here this is not the case. The secondary name node here is only kept for checkpointing. By default it is 1 hour, but it is configurable parameter. So it copies the metadata and keeps with it. Yes, Shrikant is asking, can we change the IP address if it is configured in DS? Yes, we can change, right? So whatever configuration you give in the DNS and all, so it will work that way. Okay, so this is an important point to understand from here, that secondary name node keeps a copy. So this is a little bit introduction to the storage part, right? HDFS part. Similarly to HDFS, the another part of Hadoop, important part was MapReduce. So what is MapReduce? As I was telling you, MapReduce is a framework. It is a brain. So it is platform independent and it is also program independent. So when you run a job on Hadoop, you can either write the code in Java, you can use Pig, you can even use your Python script. There's a concept of streaming in Hadoop, which we'll see. You can write in anything and submit a job, and it will run on Hadoop framework using MapReduce. But what is the actual concept of MapReduce? Okay, I have a question here. So Shamik is asking what should need to happen after the main name node comes up. See, in a typical environment, what happens is, if the name node comes up, the name node daemon on the primary name node will not come up automatically, right? So you have to have a manual intervention, right? So there's a concept of automatic failover also in name node, but which is supported only in Hadoop 2.0, which we will see. Currently we are talking about the very basic concepts of original Hadoop, which is Hadoop 1.x. So where you do not have concepts of automatic failover. So it's always a manual intervention. So wherever your name node daemon runs will be your primary name node. So in the case of a MapReduce, as we were talking, so there is a concept of a key and a value. So what is a key and a value? Let's say in a typical file which I was showing you, this file, let's say I have a file test, right? So I want to count the number of words. Each word, I have to count each occurrence of each word in a file. So what happens in MapReduce is, each of this word is taken as a key, and the number of time it has happened will be its value. So the key will be this, value will be 1. Again, I is a key, value will be 1. Again, file is a key and value will be 1. So what is happening in the case of MapReduce? It is taking each of the input and splitting it and taking it as a value and a key and a value pair, right? Okay, just give me a second, guys. Okay. Sorry guys about the interruption. Actually, some disturbance. Okay. So I was telling you the MapReduce concept. So each split is taken as a key and it will take a value for it. So what happens at a deep level, right? When we go into a discussion of MapReduce. So when we say HDFS file system, so the HDFS file system will also have blocks, block size. So in a typical ext3 file system, your ext file system will have blocks, right? A block will be of, let's say, 4 kilobyte, 2 kilobytes, right, of the ext file system. Similarly, on the HDFS file system, there will be blocks. In Hadoop case, HDFS case, the default block size is 64 megabytes, 64 MB megabyte, right? Which is again a configurable parameter. You can set 128 to 56. 128 is the mostly used one in the clusters in the production. But by default, if you configure Hadoop and you do not configure any parameter for block size, by default, each block of your Hadoop will be 64 megabyte, right? Which is quite large as compared to a native file system, right? Which is was typically 4 kilobytes, right? In the case of ext3 and all that. So each split, so let's say I have a file which is 128 megabytes and I copy that file onto HDFS. So what will happen is that file will be split into 2 blocks, each of 64 megabyte, right? Each of 64 megabyte. So there will be 2 maps which will run for that file. If I want to do a processing on that file, there will be 2 maps which will run for that file. There will be 1 map per split of that, right? So 1 map acts on 1 block. So if a file is split into 2 blocks, so there will be 2 maps, right? So obviously there are a lot of details here, but we are building the foundation, right? So depending upon the block size, there will be maps. So that's why the use cases on a Hadoop cluster will be for your large block size. Hadoop doesn't work very well for your smaller block chunks, right? Because let's say if I have a file, so many small files, right? Then we will be wasting our map for our smaller files, because 1 map can typically work on 1 block size, which is 64 megabytes or 128 megabyte. But if we load a very small file, which is 1 kilobyte, right? So we might be wasting 1 map slot for a very small file, right? Because when a map runs on a Hadoop, each map takes 1 gigabytes of memory by default, and each reduce take 1.5 gigabytes of memory, right? So to make best use of it, to have a proper utilization of the Hadoop cluster, it is to avoid the smaller files. So in this case, what is happening here is the map reduce will have 2 phases. One is the map phase and the reduce phase. Map is mapping to each split of the input, as I told you, right? Depending upon the size of your input, it will be mapped to each split of the input, and reduce phase is kind of combining it. So I was giving you an example of typical count, right? So what will happen in the case of a count is, let's say a typical on a Unix. So let's say you want to do a count on occurrence of, let's say, HTML, in how many times the a particular string or a line with HTML happened in a file. So let's say you have a file which is log. So in a Linux system, how you will do, you will cat that file, you will sort that file, and you will find a uniqueness for each occurrence on that, right? And you will write the output. So this is what actually MapReduce is doing. So map is doing a grep, right? Map is doing a grep. There is a sort phase, right? When we say MapReduce phase, so map and reduce is not the only phase which happens in the Hadoop framework. There will be a sort phase, there will be a combiner phase, there will be a shuffle phase also which will happen. But in top overview, when we talk, we say MapReduce, right? So there will be a map happening and there will be a reduce happening, right? So maps works on each split, but the final reduce phase will be 1, right? There will be one reduce. So all this will be much clear. all this will be much more clear when we talk into MapReduce lectures. Okay, I see Naveen is saying that there is some disturbance in voice. Naveen, is it fine now? Okay. I think sometimes some network glitch happens or something. Because of that, sometimes the voice drops. So in summary, what happens is client. So client can be anything. So I might be accessing a Hadoop cluster from my laptop. I might be accessing it from a desktop or any typical machine. So the typical environment will be two parts in a Hadoop. One is the storage, which is HDFS, and the brain, which is MapReduce. So we have talked about name node. We have talked about secondary name node. Secondary name node is the one which talks to your name node. See, important thing to notice here is data nodes do not talk to secondary name node. The secondary name node is not aware about what data nodes are there, because it is only talking to the primary name node and taking a backup of the FS image and the edit file. It's called checkpointing, metadata. It is taking backup of the metadata. Another important thing to know from see from this slide is, you see these arrows are pointing down, right? So it does not mean that name node is going and fetching all the blocks from data nodes, right? It is more of showing you a kind of a metadata fetch direction. But actually what happens is, name node never goes and pulls anything from data nodes. What it tells is, the data nodes, they advertise or broadcast their blocks to the name node. Name node will just capture it. So it all happens on RPC's call, RPC based call, right? So you specify your ports. So in our case, I showed you port was 9000. So the data nodes will talk to name node on port 9000. It will broadcast its block. It will broadcast its communication. It will send its heartbeat that I am there, I am there. But name node will never go, because just imagine in a very big cluster, if you have 4000 nodes, data nodes, one name node going and fetching from 4000 nodes will be very, very resource hungry for the name node, right? It will not be very practical. So the model of the Hadoop is, the data nodes, slave nodes are the one which will always advertise whatever it has, right? Name node will not go. So do not confuse the direction here showing that the name node is the one which goes to each data node and fetches blocks. It is to do with the arrows here, they are showing about the metadata, right? Let's say I was showing you an example. When you do ls on a test file, actually all the communication has to start from name node, because name node is the metadata. So metadata, name node says, okay, I have the file test, but that file is on data node 1 or data node 2. Go and fetch there, right? It is telling you that. Similarly, job tracker. So job tracker is the master of MapReduce, and task tracker will run on each of your data nodes. So how many task tracker you will have in a cluster will be equivalent to the number of data nodes you have in your cluster, or the equivalent to the number of slave nodes you have in a cluster. You have 10 slaves in your cluster, so you will have, you can have 10 task trackers. Obviously you can run less, right? But you cannot run more, right? If you have 10 data nodes in your cluster, you might want, let's say, okay, I want to run only 4 task trackers and 6 will be acting only as storage units, right? It is possible, but you cannot run 11 task trackers if you have only 10 data nodes, right? So each of your task tracker, right, will run a map and a reduce phase. Each of your task tracker will run your map and a reduce phase. When the actually a job is submitted, right? Let's say you want to do a word count. The job tracker will be aware that where that particular file is. Let's say in our case test file, we copied test file. The job tracker will know where the blocks of that test file are, right? By contacting job tracker also talks to the name node so that it can fetch the metadata, and it will know where the blocks of these file are. So it will try to launch a job on the data node where that particular file blocks are, so as to have locality of reference, right? So it will launch map and reduce tasks on that particular node, right? So obviously there are a lot of factors. It will depend upon how many maps you will have. One is the number of splits you will have on a file, and also how much resources you have available. Because as I told, each map needs 1 gigabytes of memory and each reduce 1.5 gigabytes of memory. So let's say if you want to run 2 maps here, right, and you have only 1 gigabyte of memory, it will not be possible. So you will run first one map and then the second map, right? You cannot run them in parallel. So all this will talk about cluster planning and performance when we see. So this is today we are just doing an introduction here, right? What each contains, right? Obviously there will be a lot of things. Now somebody might ask me, let's say if this data node slave machine, I have 4 gigabyte of RAM, so I can run 4 mappers here, right? But it's not about only the memory. It is also about the processor. If you have a processor with 4 cores, right, then only you can run all the 4 mappers in parallel, right? So let's say if this data node 1 has 4 gigabytes of memory, and let's say there are no reducers, for example, right? The job which you submit will always have a map phase, but it is not mandatory that it will have a reduce phase, right? A job can have a map and a reduce phase, both, or it can have only map phase, right? It will depend upon what kind of input you want to do, right? There might be a case where you do not want to do a sum, right? Let's say, right? So it will depend whether a reduce phase is not there or not. But let's say I have a data node 1 with 4 gigabytes of RAM. So for a typical system admin, it will look, okay, each mapper takes 1 gig, so I can run 4 mappers, right? I can run 4 mappers, right? But whether I can run all 4 mappers in parallel or not will depend upon processor, how many cores I have, right? So in another case, let's say on this machine I have a 4-core CPU, right? But I have only 2 gigs of RAM. So although I am capable of running 4 mappers in parallel, but my memory is the constraint here, because I can only have 2 gig of memory, 2 mappers. So 2 mappers will run at one time and 2 mappers will again run in one time. So parallelism will all depend upon your resources, how many processes you can run in parallel, what memory each node will have, right? All these factors will play a very important role in determining that. So I have a question from Janardhan. He is asking, what is the typical configuration we need to have Hadoop install? Okay, so typical condition will be master and slave will vary. So in the case of a master, your entire metadata of your entire Hadoop cluster resides in your memory, right? Resides in your memory. So the memory on your name node will always be more. So what will be your memory? So now somebody might ask me, okay, that question has not come in this class, but obviously we will look in all these details, but nobody has asked me what will be the biggest size of a cluster. I was giving you an example, right? 4200 nodes. So how you say the cluster size will be 4200 nodes? Why not more? Obviously I can have less. So when I say, let's say a cluster can be, for example, if I say the biggest cluster you can have is 1000 nodes, for example, right? So how you say that the biggest cluster can be 1000 nodes? Why not more, right? So the limiting factor is the memory on your master node, on your name node. Why? In Hadoop, everything is represented as an object. What does it mean? Every block on the HDFS is an object. Every file is an object. Every directory you create on the HDFS is an object. Each object in Hadoop by default occupies 150 bytes in the memory. So what does it mean is, let's say in an ext3 file system, you have 4K block on the ext3 level. But to represent that 4K block on the ext3 level, there will be some data structure which needs to sit in the memory, right? That inode data structure. So that inode structure will need some memory in the memory, right? Need to occupy some memory, right? So that it can go and refer the file system. So similarly, in the case of Hadoop, right? As in the case of Hadoop, each object takes 150 bytes, right? It's BYT, 150 bytes, right? So let's say if I have a Hadoop cluster with 1000 blocks, right? 1000 blocks multiplied by 150 bytes will be the memory required in the name node to keep that metadata, right? So that all will be defined by that. So Shrikant is saying as far as you accommodate all the metadata, absolutely correct. Absolutely correct. So how big your cluster will be? As long as you can accommodate your metadata in the RAM of your name node, that big will be your cluster. So it has not to do specifically with the number of nodes. It has to do with the how many objects you have in your Hadoop cluster. So case might be, let's say I may have 10 data nodes, each with 1 terabyte of disk, right? So I have 10 terabytes, right? Storage is 10 terabyte. Now somebody might say I have 10 data nodes. In another case, I may have single node with 10 terabyte of disk, right? So both are using the same kind of memory requirements in the name node because the number of objects, the number of blocks in both cases are same. In one node, in one case I am doing 10 terabyte from single node. In another case, I am doing 1 terabyte from each of the 10 nodes, right? So when we say the Hadoop cluster, I have 10 nodes and all that, the important thing to understand is you should ask how many objects or how many blocks you are presenting to the name node. So that will decide your size of the cluster. So all this we will look in detail, right? What will be the size? So important thing to remember here is each block or each object occupies 150 bytes in the memory. So let me give you an example so that you understand it better. So let's say I have a file1.txt, or let's say taken our case, we copied a file called test to the HDFS. And let's assume my file is 128 megabytes. I have a file test which is 128 megabytes in size. So what will be the memory used by this file on my name node? Right? What will be my memory? Can anybody tell me? Let me repeat the question again. Let's say I have a file. Let's say file name is test. My file is 128 megabyte and my HDFS block size is by default 64 megabyte, right? So what will be the memory used in the name node? Okay, I 300 bytes. Muthu Lakshmi is saying 300 bytes. Okay, so why Muthu Lakshmi is saying 300 bytes? Because my file is 128 megabytes. That file is split into 2 blocks, each block of 150 megabytes, right? Sorry, split into 2 blocks, each block of 64 megabyte, right? My file is original file was 128 megabyte, so it is split into 2 blocks now. So each block takes 150 bytes. But there's another factor here also, right? 150 bytes you need for the file name as well. So the total occupied space will be 300 bytes plus 150 bytes. So the occupied space in the memory will be 450 bytes for my file. Why? 150 each for the 2 blocks and 150 for the file name text, right? Because that is also an object. Text file name is an object, directory is an object, each block is an object, right? So if I copy a file which is 128 megabyte in size, my memory requirement on the name node will be 450 bytes. Correct? So that way we decide what will be the size of our cluster. Right? Naresh is saying 155. So yeah, 150 bytes will be for your file name, which is test. But that file is consisting of 2 blocks. So each block needs 150 bytes in the memory, right? Although on the disk it is 64 megabyte, right? HDFS space. But in the memory it needs a structure to map to that, which is 150 bytes. So 150 bytes into 3 is 450 bytes you need in the memory. So all these details we will see in detail, right? When we talk about cluster planning, how we do, right? It's not, we cannot blindly say that I can have 1000 nodes, right? Another important question you need to ask is, what is the storage you are representing from each node? How many blocks you are advertising from each of the node? If he is saying I'm advertising, say, let's say 10,000 blocks from each node, right? Then your total number of nodes you can have will vary. And if somebody is saying I'm advertising 1 million blocks from each node, then your size of your cluster will change, right? How many data nodes you can have, right? So it is not directly in relation to the physical blocks in relation to the physical boxes. It is in relation to the blocks you advertise. Okay. Okay, let's come to the poll here. Poll is like, I will shoot out some questions on you, which you will see on your screen, which will be related to the things which we have covered, right? So it's just to check whether you got the concepts right or not. Obviously, there will be a lot of questions in the LMS as well on this, but this is only from the class prospect. So question is, what is a data node in HDFS? Right? So the options are individual machine in the HDFS cluster that holds the data blocks. Right? Do not confuse this with client machine. Right? Client machine is something else. We will see that. Right? Each of the data node is a slave node, which is actually holding your data. But client might be a machine which does not hold data, right? So client is not the right answer, right? So HDFS is a device which holds the block. So B is also wrong. Why? Because it is not SAN. Although it's a storage device, data node is a storage device, but it is not SAN. It is your local disk. Another question. Every slave node has 2 daemons running on them. That is data node and task tracker in a multi-node cluster, right? The question is, every slave node has 2 daemons running in them, right? So that is true, because on data node what you will run? Data node daemon and a task tracker daemon, right? Your name node daemon runs on your name node, on your master name node. Which of the following stores all the metadata for your file system? Right? Name node. So everybody said name node. Yes, absolutely correct. So name node is the one which stores your metadata. Hadoop is natively written in Java, right? So that's why if you write some code in Java, it will have a better performance than writing in any other code, in any other language, right? This is also a similar question. Which node is the master node of the HDFS? Right? Answer is name node. So I was telling you what will be the size of cluster. So size of the cluster could be, let's say, in the case of if I have 1 million blocks and my default cluster size is 64 megabyte, right? So you will roughly need around 4 gigabytes of memory on the name node, right? So if you do the calculation, multiply and all that, so that way you will decide how many name nodes you will have. But in a typical companies like Facebook and Yahoo, you will be running name nodes with 144 gigabytes of memory, right? 144 gigabytes of memory, which can handle different nodes. Okay. So another thing which we need to talk about is what are the roles of a Hadoop administrator, right? Up till now we have seen that, okay, there is a Hadoop administrator and you guys have come for Hadoop administration course. But what are these market prospects, right? What are its market prospects? So nowadays, you see every now and then, everybody is talking about Hadoop, big data, right? Even a smaller companies, they might not have a very big cluster, but even a 10 node cluster, right? Any company which is into social marketing, any company which is in interface with the end customer needs to analyze their data. And for that, they are moving to Hadoop. So if any organization which has a cluster, it might be a 10 node cluster, right? So you need an administrator. You need a Hadoop administrator, right? So it is easier to switch to Hadoop administration or administrator job from a system administrator if you are a system administrator in an organization. So what are the typical roles could be? Performance tuning a Hadoop cluster, because this cluster, Hadoop setup will be entirely different from the way your typical Linux cluster works, right? You might be needed for job scheduling, patching, upgrades, recovery, monitoring the cluster, troubleshooting the cluster, right? So all these things, although we will see how you upgrade, backup and recovery and all that, but these will be the typical roles an admin will have. So the best way for switching to an Hadoop admin for a fresher would be to switch within the org which is running where you are working as a typical system admin. Get into a team and start contributing to them within the organization, right? For somebody who is a fresher. And about certification, right? Okay, somebody is asking me about certification as well. Shrikant, okay. So there are certifications available in the market like say Cloudera. So Cloudera, as I was telling you, Cloudera is more of objective type. So what happened here in the Cloudera is they will give you an objective type test and you have to select the right option, and 70% is, I think, the passing mark. So, but in edureka, what will happen is your exam, your certification exam will be more of hands-on based. It will be more knowledge, practical knowledge driven, right? So here you will be asked to, let's say, set up a cluster, 2-node cluster, set up particular parameter, set up a block size, set up a secondary name node and show whether checkpointing is happening or not, or upgrade a Hadoop cluster, right? Let's say you might be running your Hadoop with version 0.20, upgrade to Hadoop 0.21, right? So your exam will be much more based on what your real production needs will be, right? It will not be objective type. So Santosh is asking what is the percentage of developers and admins in a typical organization. So when you say dev guys, right? So as it is written mostly to Java, right? So the existing Java team or Java programmers, they can fit into an Hadoop framework with little training, right? And the Hadoop admins, right? So what will be the percentage? In a typical company, there will be more dev guys for an admin ratio. Ratio will be more, right? So typical companies, like, they will have 4:1 ratio. For 4 dev, there will be 1 admin. And also it will depend upon the size of your cluster. If you have a very big cluster, there will be more number of admins, right? But most companies which start with a smaller cluster will have 2 admins in that. Okay. So we will be ending our today's class with a little bit of overview or a kind of a glimpse into what is the later versions of Hadoop. In Hadoop 1, we have seen that our name node, there is only a single name node. So it is the single point of failure, because this is the metadata storehouse. If that goes down, our entire cluster goes down. But in our newer versions, which is Hadoop 2, we can have more than 1 name node. This is a concept of high availability. Do not confuse, as I was telling you, secondary name node as the high availability. In Hadoop 2.0, we can have a cluster of name node. This is high availability. So we'll look into that. Also, our job tracker and task tracker has been replaced with a new resources, new daemons, which do the task much better, right? So we will look into Hadoop 2.0 as well, right? So we look into how the MapReduce version 1 and MapReduce version 2 differs. So there's a new layer which has been introduced into Hadoop 2.0, which is called YARN, which is called yet another resource negotiator. So the purpose of this slide is not to like give you what we say a skip on the topic or all. This is kind of and glimpse into what will be coming in our weeks ahead, so that if somebody wants to do a self-study and all that, needs to understand how you can have more than one name node, so they can go and self-study and read some documents so that they are ready for the next week classes, right? It's more of a glimpse. So all these things we will look into detail in our coming sections. So this is what R2 can have, Hadoop 2.0 can have. Instead of having only a secondary name node, we can have an active and a standby name node, which talks to data nodes, right? And you can have a shared filer NFS location, which could be, which will be having a edits file there. So both name nodes, active and standby name node, they can both go and fetch it from a common shared location, right? So this will be a typical architecture. So all this we'll look in detail. So this is just for the sake of your kind of a heads up, so that if somebody wants to go and read what Hadoop 2.0 is, so they can do a self-study. So what will be your assignments and homework for our week 1 will be, you go into LMS, right? Go into LMS. The very first thing is, everything we will be doing hands-on anyway. I will be showing you how you set up Java path and all that. But you go is at least look from an admin point of view, look at how you install Java. Whether you use Ubuntu, CentOS, Fedora, RHEL, doesn't matter. So just look into how you install Java, how you set up path, right? What do you mean by path here, right? Here I'm running the commands Hadoop, right? I'm running command Hadoop here. But actually how I'm able to run Hadoop command is, actually I have set up path. If I do Hadoop which, right, it is coming from a profile. So here I have set up my path, right? So all this I will show you how you set up path and all that, but be ready, right? So you look at how you install Java, right? And if somebody wants to do a deep study, they can go in other sections. Another thing is Hadoop installation. If somebody wants to try by itself, in the meanwhile, before we go into the next session, they are most welcome to do. Here, this is the doc which talks about my setup. You can set up a single nodes. So here, what you can do is, if somebody, let's say, is not from a system admin background and he doesn't know how to install a virtual machine inside this, right? So what he can do is, he can go and download a ready-made virtual image from Cloudera site and run it into virtual machines, right? When you go to a Cloudera site, you will have an option to download your virtual machine, whether for VMware or for VirtualBox. It's your choice. You can download whatever flavor you want and make it running ready, right? So it depends upon what you are comfortable with. But the most important part is, you will go to your module 1. You will see your class 1 recording uploaded there in around 4 hours time from now. You can go and re-watch the video. Your presentation will be loaded there. So there will be Hadoop installation guide, and there will be some Linux, very basic Linux command. So somebody, let's say from a Windows background, he might not be aware about the Unix environment, right? So requirement will be just go through the basic Linux environment, right? So it gives you a little bit of background, how you navigate through directories, right? What is shell and all that. And there will be week 1 assignment, right? Week 1 assignment and the quizzes. So please spend some time on that, right? So the version which we are using here, right? Assignment for you will be execute your Linux basic commands and see how you set up Java. And as I was telling you, you can go to Cloudera site and you can download your ready-made virtual machines from there if you do not want to or do not know how to set up a virtual machine environment. So the environment which we'll be using here, we will be using in our distribution, we will be using Hadoop, Apache Hadoop distribution. We'll be using different versions like .02, .22, right? And then we'll be using 2.2 and different versions. Why we are going for Apache Foundation distribution 1, right? Because this will give you more of hands-on. If you go with the Cloudera distribution, we download the VM, install packages by using RPM command. It sets up everything for you in a very easy way, right? So it will not give you kind of a hands-on which is expected from a system admin or hands-on which is expected from a Hadoop admin, because Hadoop admin should be able to configure everything manually, right? Although there are tools available for doing things easier. Let's say you go and deploy Cloudera Manager, it will provision your virtual machines automatically. You do not need to do, but that's not our intent, right? We need to look each step by step, each thing step by step, and we should be able to configure each and everything step by step. So we will be taking a little bit the hard way, the Apache distribution of Hadoop we will take, right? And we will go manually. We'll take a tarball, we will extract it and do it, right? Rather than going by the Cloudera way. Cloudera way, what is it? You just do RPM-IVH install a package, it will install package, config files will be there and you start daemon and all that, right? So you will not have the right learning that way. Okay, I have a question from Naresh. Naresh is saying, I have a doubt here. Initially you said that it is recommending to maintain OS version throughout the cluster. If so, then when I want to update all the nodes to latest OS, it will be very difficult. No, see, if you want to upgrade to the latest OS, right, you will be going between the same distribution, right? Let's say I'm running RHEL, right? Let's say I'm running currently RHEL 5.4, for example, in a production. I need to upgrade to, let's say, RHEL 6. So I will not upgrade those to CENT 6 or Fedora 6 or a 126 version, right? I will go within the same distribution. So upgradation will be easy, right? We will go within the same distribution. Yes, there are instructions available. While instructions are available in the LMS. Yes, there are. Yes, Naresh is saying unmute people so that they can ask questions. Yes, we can do that. Naresh, we can do that. We can follow that practice sometime. But what happens is because there will be a lot of participants in the class, right? So it will not be possible for me to allow everyone to come and speak. But what we can do within the courses, let's say we can unmute somebody who wants to, let's say, talk about some question or some concept. We can do that within the course. That is fine, absolutely fine. We can do throughout the course. Okay, guys. So please log into LMS and you will see all your docs here about Hadoop installation, how you do that, Java, your recordings will be there, week 1, everything will be there. So week 1. So this is week 1. Okay, guys. So please spend some time, at least if you are, I'm not expecting you to set up a Hadoop cluster and keep it running, right? Because we will be doing that. But at least set up your virtual environment. Decide on whatever tool you want. VMware Fusion, VMware Workstation, VirtualBox, Parallels, Gen, whatever you are comfortable with. At least get your machine up and running. Set up a virtual machine. Take any Linux flavor, Ubuntu, CentOS, whatever you are comfortable with. So be ready so that we can get started with our Hadoop hands-on. Yes, Santosh is asking. So first step on Mac is to install Oracle VM VirtualBox. Yes, Oracle VM box or VMware Fusion. Okay, Janardhan has a question here. Okay, he is asking any good books for Hadoop administration. Okay, so the best book to start on with is Definitive Guide, Hadoop Definitive Guide by O'Reilly Publications, right? So this book is very well suited both to dev guys and the Hadoop admin guys. So this book has 3 or 4 chapters dedicated to only Hadoop administration, and then few chapters devoted only to the Hadoop developers. And there are also topics on performance tuning. So once you are comfortable with that, you can go to a book, Hadoop Operations, right? But to start with Hadoop Definitive Guide by O'Reilly Publication. If you search on Google, you will find a lot of PDF available for this book. You can download, right? So that's the book to start with. Okay, I have another question here. Yes, Miftah, you can do. You can install VirtualBox in Windows also. There are versions available for VirtualBox for Linux, Windows, Mac. Whatever base OS you have, you can do it for. While is asking, are all these VMware software you mentioned listed somewhere? Yes. So what you need? You need whatever your base OS is. Your VirtualBox is available for different platforms, Windows, Mac, Linux. Choose the appropriate version depending upon your base OS. Similarly, VMware is available for different platforms. VMware Fusion is the name for the Mac version. VM Workstation is available for your Linux platforms and Windows platform, right? So you take whatever you want. Okay guys, so any other questions, or else we can close this our week 1. And please at least download the stuff you need, right? I'm not saying configure your Hadoop cluster. At least download whatever virtualization tool you want for your respective OS, and have at least one Linux machine running in that virtual environment. Whatever flavor you want, 1, 2, I don't care, anything, right? So what is the requirement for running Hadoop is you should be able to run Java on that. That's all, right? Okay guys, so if no more questions, then probably I think we can end our this week and see you I think tomorrow, right? Tomorrow same time we have our week 2. So see you tomorrow in approximately next 10 hours. So please be prepared for our week 2. And have a great weekend ahead. And it was great talking to you. And I will love these sessions to be interactive. It doesn't matter if we overshoot, right? Today we overshoot by approximately 20 minutes. So in our future lecture, we will be doing lots of hands-on. So I do not mind shooting over time if others do not have any problem, because the best learning happens only through interaction. Okay guys, thanks very much, and see you see you tomorrow. Yes, Shamik, we have another class tomorrow, right? Tomorrow Sunday at the same time at 8. Oh, sorry, I said 10 hours, sorry. It's 22 hours from now. Yeah, right. Okay, thanks very much. Bye-bye and have a nice weekend ahead.
The organizer has ended the session, and this call will be disconnected.